So I'm just going to go try compiling and running the tests again because maybe I messed something up. Hello. You need someone to tell you how to feel about the Ditman stream. I don't even know what that is. Is that the guy that people think is pretending to be Elon Musk? Should we open up a Discord server so the people who like the things I say can connect? Well, we already have a Discord for this channel. And if you want to go there and be reality based, that's great. It's the guy. Wait, is it actually Elon Musk? No. Okay. It is though. All right. I mean, I've seen several Chinese Elon Musk videos that are all entertaining. Okay, so I have already read some of this article. So I'm going to like fast forward down a little bit. I haven't read that much. Um, I probably was here, right? And we might skip ahead a lot in the middle because, like, I know ECS solves the wrong kind of problem. Rust people don't seem to know that, but I know that. So I don't know. What's the TLDR in the article so far? I mean, it seems pretty reasonable, which is why I'm reading it. Most stuff about programming languages and game development, even, I just wouldn't bother reading. But this seemed pretty reasonable and well written, so I'm going to do that. So, anyone who wants to get started while I go make the tea um, can go here and read the beginning, and maybe you could catch up. And I'm just going to keep reading, and I'm just going to say what I think about it as I'm reading. And you know, the goal is not to language bash, right? It's very easy to language bash. Um, Obviously, you know, I make a programming language that is not Rust, so I don't want to program in Rust, but you don't, you know, that's a reasonable thing. It's not necessary to be like, you know, an internet freako about it, right? So, if it was really Elon Musk, wouldn't the alias have more of a ridiculous name, right? Like Harry Balzac, or like, you know, something like that. Why would it be Adrian Dittman? All right, back in a minute. Okay. So what's going on? What's going on? All right. So this is from a developer who made some stuff in Rust for a while, and as is unhappy with that. It was written, 9 months ago, 8 months ago. So this is not new news, but I hadn't seen this article because I tend to be pretty busy. All right. So let me backtrack to find a part that I definitely was reading. Yeah, I read this for sure. Yeah, this is a common. So basically, what he's saying is equivalent of what I often say, which is just like Rust wants you to write a correct program the first time and will not let you compile, right, if they detect problems in it, right? And the problem is that that's not um, it's not very realistic when it comes to like how people actually program, right? And so as you're deciding, like, let's just say something simple, like one particular algorithm to do a thing, you always have a bunch of choices about how you might do that. Maybe I'll do it this way, and maybe I'll do it that way, right? And you try doing it one way, and it kind of comes out more messy than you wanted. And so you try doing it another way, and then you're like, okay, wait, this isn't good either, but it gives me an idea how to do the first one. So you go back and do the first one, but better. Like, this is very common in programming, right? And like, your ability to move through this space with a rough, drafty idea and to try it out and see how it goes is like really important for productivity, actually, for high productivity programmers. Now, again, like one of the things I think we have to acknowledge for any of this to make sense is there's a difference between high productivity programmers and low productivity programmers, right? Like a low productivity programmer is like, okay, you expect this person to write 10 lines of code a week or something. Like, that's probably what Google people do now. Like industry average lines of code per day used to be 10 lines of code per day, going back to the 1970s. And I used to make fun of that all the time, but I'm pretty sure we're below that now, right? If you don't count AI generated code. All the checks can be deferred to runtime if you want. No, but you have to go through an incredible amount of pain to do that. And then you're not really getting the static type checking that C or C++ give you, right? So that's not an excuse. That's not an excuse. It's dynamic Rust is a terrible programming language. Let's put it that way. Like, Rust is designed for you to use it statically. Anyway, so that's the thing is like, if 90% of my programming or more is not on the release candidate, 95% in the case of games at least, right? You're just figuring out how things should be before you're trying to harden them down. Okay? If 95% of my programming is this kind of fluid, I'm molding the clay into the shape that I want before we fire it. That's a good metaphor, right? You're molding the clay into the shape that you want before you fire it in the kiln, right? And you want to fire it in the kiln because you want it to be hard and not have holes poked in it all the time, right? Which is the equivalent of not having bugs. But imagine like you couldn't mold the clay because it auto-hardened as soon as you could make a shape, right? It would be a lot harder to make what you want than if you can just play around with it for hours or days and then put it in the kiln, right? And Rust is the former thing. It's like clay that requires itself to be super hardened before you can do anything with it. You've written more than 10 lines during the stream so far. Well, you are an above average programmer, sir. Do I think Rust could be mostly fixed by simply having a strict release compile and an unstrict development compile that just does not do 99% of these checks? It's unclear to me. And the reason why, I mean, maybe. I would like someone to do that experiment. Let's put it that way. The reason why that might not be the right thing is because for Rust's style of checking, right? Like, one of the things that people say when they program Rust is like, oh, it's so great. And in fact, that's what's approached here, right? It's so great. I refactored my program 5 times, and they're talking about simple programs, right? And I finally got to the structure that the compiler allows me to use, right? And so if you don't have all that checking, it seems likely to me that you would converge on a structure of the code that is completely different from anything that would ever be accepted by the compiler with all the checks turned on. Maybe that's not correct, right? Or, maybe that could be mitigated. That's just my random impression as somebody who doesn't use the language but has read what people say about it, right? Um, and so if you have to rewrite your whole program anyway, like that's not much better than just like using a totally different programming language and then porting it, right? Which nobody does because it's such a pain in the butt. So I don't know, right? But maybe if Rust checks were different or more permissive, maybe if there were, okay, Rust checks are what they are because they're what can realistically be done with the program correctness analysis technology that we have today, or not even today, right? 10 years ago or more. Which it hasn't improved much in 10 years, but maybe it will. So you might imagine a different set of correctness checks that gives you as much or more actual correctness in the output, but is also less restrictive. That would be a higher level of correctness checking technology. You could imagine that. I don't know if that's really possible. I don't know what that looks like. Rust developers at Google are reported to be twice as productive as C++ teams. That might be true. It might not be true. But again, you're all these propaganda things are not to be believed, right? But B, like especially Rust people are well known for massively overclaiming, right? So don't worry about that. But B, again, if you're talking about low productivity programmers versus high productivity programmers, it's quite possible for something to be better for low productivity programmers and worse for high productivity programmers, right? That's easy, in fact. And again, we can use the chef analogy, right? For low skill chefs, the McDonald's hamburger and French fry equipment is great, and it probably makes them faster and keeps them from messing up. For high skill chefs who want to like have their own restaurant where they do Michelin star food, they're not going to use the McDonald's burger and fry machine, right? So, and I'm not even attempting to directly analogize that to Rust because I think it's too simple. Rust is way more complicated, right, than a burger and fry machine. So it's not an apt analogy that way, but like it just illustrates it's a complex multi-dimensional space with like a high degree polynomial fit to whatever the shape is in it, right? And so you can't like take an individual anecdote like that and use it as evidence that somebody else in a different situation should use a particular thing. Have the Embark folks written anything about their experiences using Rust? I don't know. The only reason I knew they used Rust is because I was arguing on Twitter with someone who claimed that their most recent, like the finals or something, was written in Rust, and I was like, "There's no way that's true." And so I went and looked, and I don't know to what degree they actually use Rust. As far as I can tell, none of their shipping games is primarily in Rust at this time. They might have an in development project that's using it. They might have tools that are using it. I don't know. Yeah, the finals is UE5. So it might have some DLLs in Rust, right? Because you can plug in DLLs into UE5. I don't know. Um, Tiny Glade was written in Rust. Yeah, I mean, kind of, but Tiny Glade is mostly shaders and stuff. Like, there's not much of a game there. I don't know. Maybe that's an oversimplification. Okay, but that was by X Embark people. All right. So Tiny Glade is probably that's probably your data point for Rust in games, right? That's at present the biggest game that's been released. Allows them to use Angel Script for gameplay code. I don't even know what Angel Script is. The Rust team at Embark is working on an unreleased game. Okay, yeah. So we're just gonna like this is what you do. You do these experiments, and then when that game comes out or doesn't come out, we'll see how it is, and we'll see what they have to say about it. Um, they said they found it helped them on iteration speed and development speed. See, I don't ever believe any of this stuff until the project is done because, and again, that's not a Rust thing necessarily. This has been a consistent problem in the games industry since the beginning, where somebody shows up in a studio, they evangelize some new, the world is changing, guys. We need to do this new thing to make games. And then they do stuff that way. And then they go to the game developers conference and hype up how awesome it's going that just last year they started doing this new stuff and look at all the benefits they're getting, right? And then the whole thing completely collapses 2 years later. And then 4 years later, they're back at the GDC going like, yeah, that's a mistake. We're never going to do that again, right? So these things have to play out like in arcs. Very specifically, when I gave that vague thing, I was thinking about, we talked about this on stream before, but it was either Insomniac or the other Sony studio. Who decided to? I don't think it was Insomniac. I think it was the other one. What are they? The one with the like. Naughty Dog? I don't know. No, it was the one who made the game with like where it's kind of like Jet Set Radio, but you're fighting dudes all the time. The game that didn't do very well. Insomniac. Okay. So maybe it was Insomniac. But the point being, they came to GDC and they were like, dude, the world is changing. It's so much better if you could just run all your tools in the web browser because people don't need to install stuff. So for Sunset Over, I believe it was for Sunset Overdrive, the game, we're going to port all our tools to JavaScript. And it's awesome because the friction is so much less. And they gave a whole speech at GDC about this, right? And yeah, then they came back years later and they were like, oh my God, that was the worst decision ever. But at the time, they were hyped and they were just telling you all about all the benefits and what a great idea this was, right? So, so yeah. Um, Ready at Dawn claimed they were switching to Rust back in 2018. Yeah, you know, dude, 2024 was a very brutal year for game studios. And in fact, we're still in that time. So I don't blame any studio for shutting in 2024. You don't get how people in tech buy into the hype so easily. I don't know. It's very weird. So even back when I was in college, I think the 80s and the 90s was a time when there was just a lot of bullshit tech demos all the time. And so if you were at all perceptive, I think you noticed that and just became inured to it. But um, at some point, there started being less of those for some reason. Because like all the startup companies were just doing like B2B SaaS and whatever. And you don't like B2B SaaS is not about being glossy or the future. It's about meeting someone's business case or what. So the culture changed to not have these bullshit glossy demos all the time. But now that we're in AI zone, man, that's all started up again. So there's all these bullshit demos, you know, claiming that their AI system can do this and that when it can't really do it, right? And that's going to be the trend for the next few years. They have now decided to move away from the web space, of course, because it's awful, right? But can someone TLDR why the browser tools were such a mistake? They might actually have a speech at GDC that you could find about this. But you can imagine all the normal reasons. Performance, JavaScript is a much more just buggy, soft language. So it's much harder to create correct code in it. I mean, you could try going to TypeScript or whatever, but like that has its own problems. Inability to share code with your game because your game is not in JavaScript, right? And so like if you have common functions, they all have to be ported, right? And if you have a tool suite, right, then your game could interoperate with the tools by just like opening a channel on the local machine or something and talking through a DLL. If you talk through a DLL, you don't even need to serialize anything, right? You pass the pointers to the data structures and you just render the stuff and you're great, right? If you're talking to a browser JavaScript, you have to like serialize everything and pipe it over a connection. And that's annoying programming to do, and it's slow. And your connection drops once in a while and you have to reload the fucking browser page. Like, there's just so many problems with it. Andreas Fredrickson did a GDC talk in 2017 with the web postmortem. Yeah, so you can look that up. I remember seeing that talk. I just don't remember any of the content of it. But it was very ironic to me because back in like 2013 or 2012, I don't know exactly when, maybe earlier, was when they announced the JavaScript thing in a talk and they were hyping it all to hell. And I was just like, oh, this is going to go badly. And it did. So, I'm going to, maybe we'll watch that later. Oh, it's on GDC Vault, dude. I don't know if I have a GDC Vault pass anymore. Maybe I can pay $5,000. So I found the page with the slides. Okay, whatever. I'm not going to pay $1 million to watch that, but big issue with Haskell in game context is that lazy evaluation doesn't play well. I would also say that the big problem with Haskell in games is that Haskell doesn't want you to manipulate state, and games are mostly about manipulating state. Like that's literally what a game is there's a giant world database of custom data structures that you edit frame to frame and visualize. There are patterns to do that. Yeah, but the language isn't made for it. Like, you're taking a tool designed for something totally different, and then you're like, oh, someone made a clunky adapter to do the thing that you could do in the other languages. And it's like, just use the other languages. Have I looked at FRP and Haskell? No, I have very little interaction with Haskell because every time that I'm just going to go read it at all, like, I can't even read the code. And I used to program in standard ML of New Jersey, and I can't even read Haskell, right? Like, so I don't know what the fuck's going on. Like, the whole thing about every function having only one return value and one parameter, is it true? Right? Haskell, wait, that can't be right. Yeah, the fucking thing where they only take one parameter is fucking retarded. It's like the worst thing ever. Like, why did they do that? It's not even probably hard to like fix that. Like, why would you make a game in a programming language where every function only has like one argument, right? Like, that's some kind of like low level compiling with continuations target language thing. Like, that's not anything reasonable that anyone should do. Yeah, there's answers for all these. Like, oh, yeah, you can use patterns with monads to pretend like you can manipulate state. Oh, yeah, you can use currying to emulate having multiple parameters. Why not just have multiple parameters? Like, why can't I just use a programming language where, um, if I want to look something up in a two-dimensional grid, I can pass you the coordinates of both dimensions. like, like what? Like what? I honestly don't think it's worth learning Haskell for me, because just every time I run into a Haskell person, they're either not doing anything interesting or they're claiming to do something insanely impossible due to the magic of functional programming languages. Like, again, I argue too much on Twitter during vacations, but I got into an argument with some dude yesterday, and it started with like AI claiming that AI was awesome and would program for you, right? And so I got into that whole dust up. And then it was like, I looked into a paper this person wrote, and it was all about like, look, if we just compile our code if you just write your code in my custom programming language, which is kind of like Haskell, but different, and then you compile down to this like interaction combinators representation, then everything is magic and your program will perfectly parallelize and there's no problems and everything works. And that was literally the paper. And I was just like, oh, fuck you. But that's, sounds like my argument with Chamath. I didn't really get that far into it with Chamath. Like, Chamath doesn't claim to understand these things very deeply. And so it's fine. It doesn't really turn into an argument. It was just me saying like, look, man, this isn't going to actually work because, and he's like, well, he just didn't really get into it, which was wise. This other person got into it, and I don't know. I don't want to sick anybody on someone on the internet, so please don't worry about it. But the point being, it's just full of these, like, one of the reasons why everybody believes functional languages, there's two basic reasons. One is, oh man, you shouldn't have state because state causes bugs, which is true to some degree, but I've talked about that before, and why it gets pathological. To summarize, the problem that happens with functional people is that every problem actually has a natural amount of state, and what causes unreasonable bugs is when you have more state than that. Like, your implementation has state that it doesn't need to have. If you have the natural amount of state for the problem, then if you try to pretend you should have less state, you also waste a lot of time and energy and make a buggier program that's harder to understand, right? Because you've passed like the inflection point of the simple program, right? So that was one part of why why I don't bother to get into functional languages is because the community is powered by these delusions, right? And another one of the delusions is this magic parallel delusion, which is actually related. It's like, look, if you program in a functional language, because we don't use state, you're going to have awesome parallelism because everything's just a function, and functions, can run independently of each other, and it's all great. And it's like, okay, actually, no. And because you still have the state of the output of one function feeding into the input of another function all over your program, and that creates data dependencies, and data dependencies prevent parallelism. And like, people just don't even have enough of an understanding of parallelism to understand what I just said. All right? And so, like, we're in the massively parallel future now, right? Like, regular GPUs that you could buy off Amazon are like way more powerful than CPUs if you can use them. And then, whatever, NVIDIA is selling to high-end customers, I forget the model names, is like way more powerful than that, right? So like, if functional languages actually achieved better parallelism for realistic problems, we would have switched by now, okay? NVIDIA wouldn't be making CUDA. They would be making Cuscal, right? H100 and A100. Yeah, those things have a lot of flops, dude. A lot of flops. And why aren't they running Kuzco, right? Because these functional languages don't actually give you the parallelism that everybody claims, not everybody, but the community at large claims. And maybe that's why I haven't heard them saying it so loud lately, but even back a few years ago, they were saying this pretty loud. And so what's the reason to get into functional languages? Because you like them and you're not worried about performance, really, is the reason. Like if you just like the aesthetic and you think it's cool to be more mathy, I don't have any problem with that. Like I think that's fine. If people would admit, and in fact, the main Haskell dude does say that, right? He's like, look, this isn't trying to be a useful programming language. It's trying to do this other thing. And I fully respect that. What I don't respect is all the people who say like, oh, it's way better than your language and you're too stupid to understand it. And it's way faster and it's going to be awesome. And it's like, none of that's true, actually. Even CPUs are 20 to 200 times faster if you massively parallel. True. I mean, even just on a CPU, if this actually worked, all the video games would be in Haskell, right? Like, dude, game developers would love to be 10 times faster than they are. Like, almost no video games are able to effectively use a parallel CPU, much less a GPU. It's just incredibly difficult. The Bend language supposedly runs on GPU. That may or may not have been what I was talking about earlier. All right, so that's background. That's just what I've been thinking about lately. Yeah, the claim behind that language is it runs on the GPU and gets almost linear speed up with the number of cores, which is just complete horseshit. Like, it's not possible. Computer science says that that is not possible. Okay? All right. Let's keep going. I've been talking too much. I have a scratchy throat now. I wonder if I have any cough drops. Wouldn't a high-frequency trading company have the best knowledge of this scenario? Not necessarily. Okay, here's the thing. HFTs care about latency, right? So games, for example, also want low latency, but they're willing to trade a little bit of latency for a lot of throughput, right? So that's why, for example, games are double buffered, because you compose the frame and you don't want any tearing, and then you flip it, right? And for a while, games were like triple buffered and quadruple buffered to try to get higher like frame rates overall. And that was too much latency for me, right? But HFTs don't necessarily care about throughput. They care about beating their competitor HFTs. And that's about latency only. And so like if a garbage collector literally ever kicks in, you're fucked on latency, right? Because it fucked up this trade that you were about to send. I mean, I don't know if they use any functional languages, but I don't think they care about using an entire GPU or anything like that. I doubt it, because talking to the GPU and getting the result back is latency. That's just how it is. And so staying on the CPU minimizes latency. They use FPGAs, yeah. Like FPGAs make sense to me, because it's like, look, we're doing this one very specific thing. We want to minimize latency in doing this specific thing. So we've essentially got our custom hardware. And so the thing about FPGAs is they don't generally clock as high. How fast are FPGAs now? The thing is, they don't generally clock nearly as high as a CPU, right? But because they're doing a very specific job, they can do that one thing faster, even though their clock rate is much lower. 100 megahertz, someone is saying. Yeah, if that's so a current CPUs are still like what, 5-6 gigahertz. What is the shitty new Intel? Let's see what I have. I have a shitty new Intel CPU, right? Can we tell the clock rate from here? Well, system summary. 3,000 megahertz. Oh my, no wonder this computer is so slow. Why did I buy a well, I didn't buy it. Someone at my company bought this. Why did we buy a 3 gigahertz CPU that still eats itself over time? That's crazy. Okay, but even with a very slow CPU like this, that's still 30 times, 100 megahertz. 10 to 30 times as high clock rate. But if you're doing a very specific job, so the FPGA has several advantages, right? One, you don't have a big ass random operating system messing you up. You don't have task switching, right? You just have hardware doing a specific thing. You don't have, unless you build it in the FPGA, which they probably don't, you don't have all this crazy hardware complexity that introduces variation. So you have exactly known performance of how long the thing takes, right? Like if you're going to do something on a CPU, maybe your thread gets swapped out, maybe it doesn't. Maybe the page is not in RAM that you're accessing. Maybe the reorder buffer puts the instructions in a different way than you expected. Maybe things are in L1, maybe they're in L0, maybe they're not, like whatever. There's all these variables, right? And what you get with an FPGA is a massive decrease in variables, in how things are running. And it's like much clearer and much more known. And so I totally get that. 3 gigahertz per core. Yeah, but like, I had a 2 gigahertz computer in 2001, right? What was my Threadripper? Maybe I should switch back to that. Clock rate. 4 to 5. Yeah. Maybe I'll just switch back. Maybe we won't even bother shutting the European cores off. Like, it's literally right there. My old Threadripper is right there. Okay. When do we start investing in Intel? I don't know. I wouldn't. But, all right. So he's talking about how refactoring a bunch is a pain in the butt. I read that before. All right, ECS. I've said this all the time, so let's check this author's take on the issue. Pointer data with actual pointers. All right. Reference count. Like, how crazy is it that even just that is a double nested templated type or whatever? What do you call this in Rust? A type with parameters. Why did they use the C++ angle brackets, by the way? That's so ugly. Generic. It's a double nested generic. Indexing into arrays of entities. Yeah. So I have a video that's quite a few years old now. It's probably from 2017, where I replied to someone's generational arena video and said, this is not really what you think it is. So he's talking about people confuse ECS and generational arenas and say people say ECS is great, but what they mean is they like generational arenas. I don't like generational arenas, but it's fine. If they're the best way to do things in Rust, given the constraints, like that's okay. Because they're at least a simple, flat, understandable, relatively efficient data structure, right? So there's that. All right. So he's talking about composition as, created by ECS is a lot more general than generational arenas. And okay, he's talking about ECS details. Yeah, so fat components, is he going to explain what this is? Yeah. So okay, let's talk about this one because this is interesting. So fat components basically means, and I do the same, even though I don't have a component system, I do the same thing with my entity hierarchy, right? So there's like a base entity, and then there's one level of derived entities, and that's it. It's a tree with one root, and then all the nodes are flat. So it's very simple. Right? There's no derived type of a derived type at all. It's very simple. It's easy to deal with for serialization and all this stuff. Now, what that leads you to is there's more stuff in the base entity. In fact, I could probably, let's go. So here's our base entity. It's got a lot of stuff in it. And it's got some stuff that not everybody uses right now. Like a lot of stuff, actually. Like, let's look at this. Charmed by, so this is a game where a character could charm another character. This actually could be factored out, but I just haven't bothered. Only monsters, there's one entity that's a monster type, and there's one entity that's a player type. Only monsters and players can be charmed, right? So the thing is, this is on the base entity, which means literally every entity, including non-interactive background meshes, has this member on it, okay? Isn't that terrible? Well, in what way? So the most obvious way is we take memory, right? But like, what's the most number of entities that we're ever going to have? Maybe in the overworld, we'll have 200,000 entities, right? Okay, so this takes 4 bytes. I think it's 4 bytes. Let's say it's 8 bytes, whatever. In our biggest level that we're ever going to load, 200,000 entities times 8 bytes is 1.6 megabytes, which is a trivial amount of memory on a modern computer, right? So like, who cares? Maybe, like I said, maybe we could factor this off in the end onto both the character class and the monster class, and then have a little accessor. Maybe we'll do that today. Like, that would be a pretty easy thing. But it was incredibly valuable, even if we do decide to do that, which we probably may not. I don't know. I went for years just throwing this in the base entity, and it was fine, right? And then the other question is like, oh, doesn't it make your code more complicated? And I think the answer to that is it depends on how it's structured. Because if you have this object-oriented idea, which Rust still carries over, even though they kind of claim they're not really object-oriented like C++, I think, well, it depends who you talk to. I think it depends whether the individual Rust programmer likes object orientation, whether they will claim it is or isn't object-oriented. But if you think the goal of an object is to have methods, then if you put this on the base, it's messy because you have conflicting methods trying to do different things, and you have to sort that out somehow, right? And so then you're kind of forced to put them in the base class and to dispatch and all that. Whereas like if you don't have methods, if you just have functions that operate on entity, then there's not really a problem. It's like there's one if statement in that function to say, is it a monster or is it a player, right? Like that's actually very simple and understandable. And so there's a way in which decisions compound. And if you're very used to it, if you're very used to living in a world where you think there have to be objects that have methods, then you might not even see that possibility that like you could actually just throw this on here and it's fine, right? By the way, animation player, animation graph, also not on any of these inanimate objects, right? All these are. And so there's actually, that's the other thing you want to think about is how hard should I work to factor off this amount of data? It's like, well, what percentage is it of the total? So let's say this rounds up to 8. We have 24 bytes out of, I don't even know, dude. Like there's so many bytes here right now. This is probably going to go away, so we won't count that. But like all this, even if we factor it out, it's like a relatively small, and this doesn't even include undoable entity data, by the way. Let's look at that. All this is also on the base entity, right? So we have pretty fat butt base entity is what I'm saying. And it totally doesn't matter. It's like, it's so far down the list of anything that I care about on this game that this, if I happen to get OCD and factor one or two things off here, it'll mostly be for future maintainability for future versions of the game or future games or something. It won't be, it won't be because I'm worried about the memory savings. And so if you go through all this pain, so that's one of the arguments for ECS, like you shouldn't store redundant data for things, and you end up doing so much complexity to avoid this. It's not worth it. Your life is short. All right? It's going to get taken over by robots in 5 years. Did you see that crazy video of the $1,600 wheeled Chinese robot that just rolls down hills and all that? All you got to do is put a shotgun on that dude. All right? Dude, a millionaire can afford 1,000 of those. A billionaire can afford 1 million of them. Now, today. So don't do ECS, is what I'm saying. Have you guys seen this video? They were showing it. If you don't know what I'm talking about. What was it called? Unitree. Okay, I think it was this one. $1,600. Notice, by the way, how the top is flat, right? Notice how the top is flat. How little effort would it be to put a rail up there is all I'm saying. It's almost as if it's designed to have things mounted on top, huh? All right, so all I have to say about that is buy a shotgun and don't use ECS. All right, life is too short. That model is 100K. All right, well, oh no. A billionaire can only afford 10,000 of them. Oh no. I only have an army of 10,000 robot dogs with shotguns. All right. Back to the article. I'm gonna get another drink. That'll only take a second. You guys can read ahead. You know, we can I think, well, you can read this. I'm gonna skip ahead past this because I already know all about ECS, and he seems to be saying the same thing that I think. So that makes it easy. All right, I don't seem to have any cough drop kind of things that I could. I probably have some somewhere, but I don't know where they are. Sad. Buy a shotgun. Okay. The great thing about shotguns also is they don't tend to carry enough rounds to be subject to any of the ammo capacity laws, right? So a fully competent shotgun is basically legal everywhere. In fact, let's check this out. I'm trying to remember. Oh man, what was it? I'm trying to remember. There was a shotgun I was going to get, and I decided not to, but now I'm reconsidering. Ah, yeah, yeah, yeah. Okay, it was the Mossberg 590. So, so just, if you wanted to carry a shotgun, right? Let's just say this photo makes it hard to tell how small it is, but it's kind of ridiculous. Um, so if you kind of just wanted this, like, strapped to your leg or something as you walk around so that you're ready to defend yourself against robots. Oh, they also, somebody makes, because it's hard to aim this thing, right? It's like, it's very short and it doesn't have good sights. So, yeah, somebody makes an integrated laser saddle for this. You can just have a little laser sight on it. Just, I'm just saying. Just saying. Did I buy one? I haven't bought one, but I think I'm gonna now. Because, like, you need some kind of anti-drone defense, right? So that you can program. What if you're sitting here trying to program and a drone just shows up outside your window? What are you going to do? What are you going to do? If you have a 590 right on your desk here, then you're covered. Throw a wet towel at it. I mean, it's outside the window, right? It's not going to throw a wet towel at you. So, yeah. All right. So he's talking about ECS. I hope you read ahead. I'm going to skip the ECS section. Let's talk about this. Yeah, this is a general belief. Okay, so here's when you go to computer school, they teach you this. If it's a good computer school, and it's kind of true, but it's one of these things that is extrapolated way out beyond the point of truth, right? Until it becomes a stumbling block, right? So if you don't know how to program yet and everything you make is a complete complicated mess, then it's very useful to understand the beauty of a generalized system that does the whole class of problem that you're trying to solve, and it's more powerful than what you were thinking about, which is like some mess of if statements or something. That's a very important step in becoming a good programmer, is to understand that. So learning about generalized systems and how good they can be is important. The problem is then programmers get this disease, and I even had this disease at one point, although I grew out of it just through experience. Programmers get this disease of trying to approach every problem as a generalized system, and there's multiple issues with that. One is every problem doesn't map to a generalized system, and two, if it does or doesn't, usually you wouldn't know when you started programming it because you don't understand the system very well yet, because you don't have experience with it yet. And so you're trying to design some beautiful generalized system that solves a problem you don't even really understand yet. That's a mistake, right? I think what you do is what the right way to approach it is just now that you've seen generalized systems and messes of if statements, just try to make the cleanest, most generalized thing that you naturally can given the problem, but also just drive directly toward the solution of the problem. And if that involves some if statements, that's frickin' fine, right? And just don't get trapped in the quagmire with the ROUSs, right? So, yeah, like that's a problem that tons of programmers have. Could I give an example of a good generalized system? I don't know. Like, this is something that you internalize at a very deep level. Let me do a really simple one. This is actually maybe more math, but it's an analogy, right? It's an analogy. When you go to grade school in the US, you get taught how to do a line on graph paper, right? And you learn how to do slope intercept form, which is a completely shitty representation of a line. And if I had a time machine, I would go back in time and change that. It's horrible. But you learn that that's how you represent a line. That's the standard way. And the problem with this is it has a singularity at a vertical. You can't represent a vertical line in this form. And in school, when it's because it's tied to algebra, no, there are better things tied to algebra than that, okay? But in school, when they teach you how to do a vertical line, they're just like, okay, look, when the slope gets really, really high to infinity, just say x equals whatever, and that's your vertical line. And so you have this essentially an if statement in the way that you think about lines in 2D. What's simpler than lines in 2D, man? But they teach it to you in this corrupt way. Now, they might have touched upon at some point that there's this other way there's multiple other ways, right? They'll teach you like polar coordinates probably, right? And they may teach for briefly for like one day, like, oh yeah, there's this thing where you could just say ax plus by plus c equals 0, and that gives you the things. But like, that's not how the educational system is organized. The problem is that latter thing is the right way to represent lines without singularities. And if you understand it, it's a lot simpler, and you can do a lot more things just with straightforward math than you can if you're thinking of a line as a slope and a frickin' y-intercept, right? It's a horrible representation. And you have to unlearn that representation in order to be good at geometry in 2D, which you need in order to be good at geometry in 3D or 4D, right? So that's an analogy, right? I remember trying to solve like geometric intersection problems when I first started making games, even in 2D. And I was like, wow, I don't quite understand how to do this intersection with this fucking slope intercept. And it's like, you just shouldn't do it that way, right? There's a better, more general way to do it that doesn't have these inherent problems, right? And that happens for code as well as for math. Slope intercept form is good if you want to talk about linear functions and not about lines. I disagree. Even if it's a linear function, when you start doing advanced things with it, you're going to want to do like little finite differences and stuff like that. And just a regular vector representation is just better. Like there's literally no reason to think about slope as being a thing. Like I understand the history of that. Like the history of it is, yeah, if you have a function of a monotonically increasing variable like time, or, time is literally the only one, then it makes sense to do that. But even time being monotonically increasing is like an illusion. So whatever. But it just learn the vector form and you're much more powerful is the point. Given the slope and a point, we can reproduce the graph again because the slope is not always defined. And then what do you do? What do you do if you can't even write down you can't even write down the line segment for a vertical line in slope intercept form. You can't do it. You have to break out of that form for one of the two most simple cases. Like, okay, shouldn't it bother you that it's very easy to write a line along the x-axis, but if you rotate your view 90 degrees, it becomes impossible. That's like treating the two dimensions totally differently, which is like the definition of a singularity and the definition of a problem. Like, look, I'm standing here. I could do this. My vision didn't freak out. My brain didn't stop working while I was rotating, right? I just did. It was the most natural thing in the world. Any representation that doesn't make that the most natural thing in the world is fundamentally flawed. You're going to have problems all over the place. You can do it too. Try it home. Turn around in a circle. See if it works. Okay, hold on though. Those of you who know about quaternions will know that I just twisted my relationship to the environment and it's now in an odd parity. So I need to turn around again. Right? Okay, so now the double cover has been resolved and we're back to an untangled state. Provided that I woke up in an untangled state, which I'm not sure. Only 1% of the audience understands that joke. Or less. Probably less. Okay. Of course, if you want to represent any line, you should use ax plus by equals c. Yeah, but that's just not what they teach in the educational system here. And it shouldn't be ax plus by equals c. It should be ax plus by plus c equals 0. That is the correct representation. All right. Okay, so we're back to the article. We're having fun, though. The fact that we're so distracted, we're having fun. Oh, is there an NVIDIA keynote soon? It's not today, or it can't be today. It's Saturday. Okay, generalized systems. This is a gray area because systems are good in games, but also games have a ton of if statements to make things work nice, right? So you like need both. Okay, yeah, he's just saying, like, look, making real things that people want to play is about more than generalized systems, right? Dude, I bet you Factorio's full of if statements, man. But it's also got a core system to move the factory bits around and stuff. Both things are true. Why do I think it's hard to build compilers? It's not that hard to build simple compilers. It's just hard to build state-of-the-art compilers because there's just so many moving parts. It's like anything. January 6th. Oh my God! It's on January 6th. Arrest everybody. The NVIDIA keynote is on January 6th. All right. Mistaking carefully thinking through player interactions as something artistic? No. Okay, this is a good point. Artist-style game developers do this. They carefully think through player actions and design them in a specific way. But so do commercial designers. Commercial designers polish the fuck out of player interactions, right? I should stop swearing as much. I'm sorry. It's how I feel sometimes. Like, look, The only difference between the person working at Zynga on Farmville, well, there's a lot of differences, but they both polish the gameplay design in specific ways and want to steer it in micro ways. It's just they have different intentions. The intention is the difference. The artist is trying to create something beautiful or interesting. The Zynga person is trying to manipulate the player to make the most money, right? That's the difference. But they all game, this is the job, this is the definition of game designer. And actually, also the definition of gameplay programmer, because a gameplay programmer is not just supposed to type in what people say. Because if you do that, it's going to be just janky and not work that well. You're supposed to then go like, hey, let me smooth out the rough edges so that it meets the intent of the design, right? I just realized the magic lamp is not on, so I'm going to turn on the magic lamp. Is it even in frame right now? Yeah, oh, of course it is. I'm going to turn on the magic lamp, but when I do it, I'm going to make sure to rotate 180 and then come back 180 the opposite way so that I preserve my entanglement relation with the environment, all right? Make sure I turn the opposite way on the way back. Oh God, I went the wrong way. Let's turn again. Okay, we're fine. We're fine. I turned too much? No, I turned twice. It doesn't matter whether I turned the same way twice or turned once and then turned the opposite way. As long as you turn twice, you're back at your original place, all right? Learn quaternions. God. You're wondering if The Witness was partially inspired by Lost. I mean, only in the vaguest way, right? Like Lost came out, like I never saw season 1 originally, and I saw season 2, and I liked that. And then after season 2, the show became crappy, like very fast, right? But season 2 of Lost was okay if that was all you ever saw. But not in any concrete way. Did I know that in quantum mechanics there are particles that are in a different state after rotating 360 degrees? Yes. Yes, I did know that. Yes, I did. All right. Binding of Isaac. This is a weird one because I would guess that there's a baseline of, I could talk to Edmund about it, but I would guess that there's a baseline of procedural composition and then a bunch of if statements on top to change how things are coming out, right? Yeah, and I think he's sort of saying that here. Game design as a search. Okay. I get what he's saying. I haven't seen this video. I think he means scrapping here and not scraping. But you get the idea. Braid is similar. Yeah, there's a bunch of if statements in Braid, for sure. At the same time, there's a general system underneath everything. right? If there were not a general system in Braid, it wouldn't be a very good game, right? It would just be a bunch of weird hacks. It would be like an adventure game, right? Where you click on things. I don't know if people know what adventure game means anymore because there aren't any. I don't mean like the Indiana Jones game that came out. I mean like point and click games. Like Loom. Like Myst. Original Myst. All right. Making a fun and interesting games is about rapid prototyping and iteration. Rust values are everything but that. Yeah. I've said this before. I'm going to skip this, or I'm going to skim it looking for things that I don't already agree with, because I already agree with this 100%. That's why I've spent so long making a programming language. So here's the thing. Maintainability is a positive attribute, right? This is why language bashing is not good. Like, there's good intent behind a lot of this stuff. Maintainability is good. But if you never finish your thing, or it's only 50% of what it should have been because it was too hard to make, then maintainability didn't matter, right? If you have no game, it doesn't matter if it's maintainable, right? Or if your game sucks and nobody wants to play it and you don't like it because it sucks, right? It's much more important to be able to get to the good game. And then maintainability matters. But guess what? Guess what? Here's the thing. Rust forces you to do maintainability. If you agree with Rust's idea of maintainability, which I don't exactly, but if you do, it forces you to do it. But guess what? You could force yourself to do it too in any programming language. You could force yourself to clean up the code. The problem is a lot of people just don't ever do that because they're tired of working on it, or they're just sad because they're depressed from eating poisoned food for decades and not going outside, or they're scared of their code because they let it get too complicated, and they don't want anything to break. But then just start a new project, copy the code over, and then break stuff. It's fine. Move fast, break things. Rust code can be very scary too. Yes, I agree. Like, I think that what Rust people undervalue is the complexity of, like, the cost of the complexity added to work around the borrow checker and all these things, right? They treat that cost as zero because they're like, oh, we feel safe because we don't have memory bugs. But like, again, I mean, memory bugs are like less than 1% of the problem in programming. And so if you pay more than 1%, which I think they're paying a lot more than that to solve memory bugs, I don't think that's the right trade-off. It just doesn't make sense to me. Do I visit solarium sometimes? I live in America. We don't know what a solarium is in America. What is that? Isn't solarium just the name of a room with big windows? Artificial tanning. Oh, is that what you call it in Europe, a solarium? We would call that a tanning salon in the US. No, I don't go to a tanning salon. I've been to one when I lived in New York, in Manhattan. I went to a couple times just to see what it was like. Because I would like walk by one every day on the way home, and I'm like, all right, let's just see. And I went like 3 or 4 times, and I was like, okay, that's what that is. You thought solarium was a room with glass walls. That is also what I thought it was. When did I live in Manhattan? 2001 to 2002, or 2002 to 2003, somewhere around there. Somewhere around there. Back during the Bloomberg times when Manhattan didn't suck. Only a year. Yeah, I didn't like it. No. It's very, I don't know how it is now, but even back then, 20 something years ago, it took a great deal of energy to go from place to place during the day. And because you have to walk and push through all these people, or you have to go through the subway, right? Whatever. You have to deal with the smelly trash on the sidewalk all over the place. Although now I heard they're going to actually start to use trash cans finally in some places. But it takes all this energy, and like, what are you getting out of it? If you're like in Wall Street, industrially, or you're in the Broadway industry, right? There's the musical industry or something. Then it makes sense. Or if you just really like dinner parties or something, maybe it's a good place for dinner parties where all the people there watch NPR and have the same opinions. But like, none of that was true for me. I just would try to go to coffee shops every day and program, and there weren't even good coffee shops, and they weren't even open late mostly. And so there was a lot of cost and no benefit to living in New York. And I didn't like I didn't like the social environment there. I felt it was very negative. There's a lot of single ladies. I mean, that's probably more true now than there was back then. I think it's gotten more one-sided. Yeah, I moved there on my own just to check it out. Okay. Yeah, I agree with this. So here's the problem: is it's very easy to point at the problem you solved and what the benefit of that is, the ostensible benefit is. What's harder is to evaluate whether you really got that benefit in all cases, and what invisible things did you give up in order to get this benefit. And I think that's what the Rust community is terrible at. They're not good at real cost benefit analysis. Right. I don't know anything about Rust procedural macros, so let's just see. I know some people say they really like them and think they're really powerful, but uh, I also haven't seen, like, again, I looked up on the internet a couple weeks ago what was an example of Rust procedural macros, and they just used it to generate a ton of uninteresting boilerplate code. And it's like, okay, why do you think that's good? Proc macros are a nightmare to write and are poorly documented, but they can do magic. I mean, I doubt they can do better than what we can already do with compile time execution, right? But I don't exactly know how they work still, because just every time I try to look at them, I bounce off. Um, all right, let's see though. What does he have to say about it? See, I mean, you'll note this article isn't written by a hater, right? Like, when he thinks Rust is doing a good job in a particular place, that gets called out. That's a good sign that what you're reading is not a random internet slop from an unthoughtful person, right? It's just it's reasonable and in context. Okay. Declarative macros. Yeah, I saw this in the example that I tweeted about. Concatenating tokens, which now is a paste crate. Nesting and mixing procedural and declarative macros together isn't going to work. Not even obvious what's possible. Okay, well, that's a bummer. For us, you just output a string, right? It's very easy. Or if you're more sophisticated, you output a code structure, which is a little more involved, but gives you some advantages, right? So, yeah. Procedural macros basically allow the programmer to run code at compile time, consume Rust asks, and generate new code. There are many issues with this, unfortunately. Proc macros aren't really cached. Forcing your code to be split up in multiple crates. So a crate is the equivalent of a library, right? Is that true? So why why would you want to do that? That sounds horrible. Crates are the unit of compilation. Oh. So it's more like a .o file than a library. Okay. That's maybe not quite as bad, but it's still, I don't love it. Okay, so this just sounds like this sounds like a lot of problems, but this doesn't sound unsolvable, right? This just sounds to me like, look, there could be a better procedural macro system than the one that is there, and maybe Rust 2 will have that or something. Like none of this is inherent in Rust type safety, I don't think. But maybe it is. I don't know. Maybe this is crufty because of the implementation details that they were forced to make because of lifetime management or something. I don't know. Okay. Popular Rust serialization crate, which is, I even have heard of Serdi, so I know what that is, which at some point started shipping a binary blob. Wait, what did they ship though? Because what did they ship that's not platform specific? Does anyone know? Does Rust have like a binary intermediate format? Click the link. Well, I don't want to rat hole too much. I mean, is it pre-compiled for every platform? Like, what did they do? Procedural macros have a very steep learning curve and they have to be defined in a separate crate, blah, blah, blah. Hot reloading. All right. So we're going to divide here. I don't like this demo at all. I think it's mostly bullshit. It's not bullshit. They're not lying, right? Like when they do this demo, they're just like, hey, look at what we do. But the thing that I don't like about the demo is most of it will not scale to a significantly sized game that has real assets. And they don't ever say that. And so it's just like, oh, come on, guys. Um, that could just be naivete on their part. I don't know. But whatever. We're not here to throw a wet rag on Tomorrow Corporation Tech Demo. But um, yeah, he's talking about hot reloading. We've talked about that before. I think it's pretty good. We don't hot reload code though, right? On my projects, I've just taken, and the reason we don't hot reload code is because it's actually impossible to do a good job of that if you change data structures, and we change data structures all the time, right? So I just say, look, I don't want the complexity of sometimes hot reloading and other times not, and having to think about whether the change that I'm making right now is going to require a restart or not. And we already have hot reloading on stuff like shaders anyway, right? So for the actual system code, I just say like, look, our compile time is fast. So that's, you just do that every time, and you don't have the uncertainty of having two ways to compile. That's the way that I went. If your compile times are a lot longer than 2 seconds, I could see really feeling like hot reloading is important. I don't think he says in here how long are the compile times for the game. But that would, you know, if I didn't feel like it was easy to compile in a couple seconds, yeah, I would be much more pushed in that direction. Much or most of software would hugely benefit from such a setup. I don't really agree. I don't agree. Because they're pitching it specifically for games. I mean, maybe if you make like, you know, command line apps or something, but like nobody should do that anyway. But anytime you're making something asset heavy, all the stuff they demo about like, look, you can just slide the scrubber and whatever, like none of that actually works because you have to wait 2 minutes for the assets to come down from the server, right? And it's like we have 3 million files in our source control, all right? Like you're just not going to be able to slide a scrubber across 3 million files when the server's in Texas. That's not how that works. So, and we're an indie game company, right? We don't have nearly as many assets as like Insomniac does. And this would like dismally not work at all for us. Most indie developers, I would say, probably don't have as big of a game as us, file-wise or asset-wise, but a lot are like in the middle where it just wouldn't work the way that they demo. And I don't mind that. Like, I don't mind showing the demo and saying, look, here's what's possible. Like, that's inspirational. Inspirational is good. But you shouldn't go into the territory of being snake oil, right? Like, you should say, you should have in your head, like, yes, this will work interactively up to a certain load. And you should delineate for people, here's where the border is. So if you're below this line in terms of how many assets you have and server performance and network performance and all that, then you're okay. But if you don't do that and you sort of implicitly claim it'll work magically for everybody, then you're just kind of a liar, right? And we should not tolerate that. And I don't exactly blame, I forget the name of the dude who did the demo. I don't think he's being too intentionally dishonest, but there is this culture in programming where you pass something off as way better than it is. And that's been true certainly for longer than I've been in programming. And this is just another instance of that. And we should stop doing that because it's been leading us into this horrible place where we have all this software that just never really, it's not the only factor, but it's one of the big factors in why we have all this software that still never really works, right? I mean, like, dude, just yesterday, I had 3 interactions with websites to do simple things and none of them worked. I tried to book a room at a hotel in Las Vegas, and that didn't work at first because the login went to an error page. I tried to, pay for express lane tickets here in two different ways, and like neither of those, like even basic web pages don't. Who are you fucking kidding? Like telling me that all this stuff works, right? Like we've had the web for almost 30 years and it still doesn't really work consistently. The only reason this page works is because it doesn't have a lot of interactive stuff. It's just like flat text. All right. You thought we figured out submitting forms. I mean, apparently not. In this case, I'm pretty sure it was a race condition because I created an account, right? It was like, create your account to get the discount on the hotel. So I did that, and then I went to book the room, and it was like error because I think there was a race condition like several minutes long between when the account was new and when the database was like fully populated and the cache for whatever was generating the page wasn't reading stale data, like all that shit, right? And it's just like, guys, if you can't do that, why are you pretending all this other stuff works? All right. It's hard. It wouldn't be hard if we simplified everything. Like, why are web servers millions of lines of code? Who decided that? Like, come on. All right. Like, I wrote a web server back in the early days of the web. I didn't ever like publish it, but I wrote my own because I was like, hey, why not? It's so easy. And then they just kept making it harder and harder, and now it's not possible for one person to do. Like it really wasn't that hard. Like implementing, reading a TCP socket, implementing get, like that's really easy. Serving static web pages, it's so easy. What happened? Did I really design the witness puzzles using text files? I mean, they're all in C++ code. Right? I mean, I've shown this before. Do I have witness on here? I might not. I do. Let's see. This is off topic, but someone asked. What's it? I forget the file name that these are in. Hold on. I think it's called puzzle panels. Why? Maybe it's in entities. Panel puzzles. Okay, so these are like 4 different. So Lotus is the speed run. These were like sort of effectively code names of areas when I was developing them. Lotus is the speed run. COTS is like the other randomly generated puzzles. The boat is the boat. And this is the main ones. So like this is a 21,000 line C++ file. And a lot of the puzzles, so some puzzles are of the form, we know there's exactly one solution. And for those, like they're literally typed in like this. All right. So like the shadow puzzles are like that. There's one solution. Other puzzles are more systemic. So if I get down to, there's this make n by m, which is just like make a grid. Like literally when we do panels, it's like, hey, make a grid and then cut edges or whatever. So if I look at who calls this, Oh, this is the cylinder version. Cylinder version does the flat version and then connects around the edge, right? So this is just calling the flat version, and this is doing the edge lists. The force field bridges. And then I literally do this at startup. I'm just like, look, just stir comp the name. And this was fast enough on computers of like 10 years ago. It was fine. Like you don't need a hyper general system sometimes, right? This is like the point. So this pattern name is literally a field on the entity, and it's like, here's how I do it. Like before I call make n by m, if it's generally a grid panel, I call this, but I can prep it by saying, look, this one don't connect in these directions and whatever. And then these are like what goes in the squares. Like it's very smooth brain code. But yeah, this is all the puzzles in the game. I mean, yeah, so early on I made an edit panel command, which I did use for some stuff, and then I would output it, which is why this looks even stupider. But that's very few panels were made that way. These are the panels at the beginning of the game. Simple maze. Those are like in the tutorial. And then, yeah, I don't know. Let's go to the speed run is more procedural, right? I don't remember what these overlay, how these are used. Am I misremembering where these are? Let's see. Let's keep going till it makes sense. Oh, no. Okay, this isn't the speed run. I was wrong. Sorry. Lotus is the speed run. This is inside the mountain. So like the color cycle panels are like when the LCD's broken. Spoilers. All right. So this is the speed run. And let's... Oh, this is for the clock, because there's a clock that's sort of in puzzle language. That's what that is. There's a lot of code for the clock. It was my Christmas project one year. I had a lot of fun with that. That was one of my funnest game development memories, was doing the clock. Oh, maybe that's mostly what's in here. Hold on. Maybe I skipped past. Okay. No, because there's not that many panels in the speed run, right? So I think they're all in this function. So Lotus gates is like when the things pop up and down, I think, right? And so we sort of we pick a random number, I think, or maybe it's just n because it's adjustable and I was experimenting. And then we cut some random edges, right? And then we add some dots. This is all completely random. And then we run a solver on it to make sure it's solvable. And if it's solvable, we accept it. Otherwise, we re-roll. And then there's some things. Let me look at this because this is interesting. There's some stuff, like there's panels that are intentionally wrong. And I think we have some additional filters. I'm looking for, I don't see that. But there's like some tests for like, is this too easy? And whatever. Anyway, that was fun. So the point being, this is really simple code structurally. It's not doing anything crazy. That's really what I want to show. What's the clock? There's at the end of the speed run, there's a timer, but you don't necessarily know it's a timer if you don't think about it. Do you have test code for Witness? We had some tests, but most of it was hand tested. Have I watched a lot of Witness speedruns and tooling? Not lately. I watched some of them in the early days, but not in a long time. Did I design any puzzles playing randomly generated ones and looking for cool ones? I didn't. The random generation wasn't in the game till toward the end. But toward the end, I did see some cool puzzles. So is that a viable way to design a game? Yeah, probably. However, I would encourage people to like have a high standard for what cool is. Like maybe it gives you the starting point and you still iterate on it to refine it or something. Because you don't really want randomly generated difficulty challenges. I don't think that's that good of a game. Would this qualify as data-oriented design? I mean, not explicitly, but it's more in that direction than a lot of people would tell you to make games. Okay, so he's talking about hot reloading. That's great. All right, abstraction isn't a choice. UI with list of characters in a detail page that appears when a duck is selected. The way UI is structured is have helper functions, all right? eGUI, I don't know what that is. Oh my God, this just looks so ugly to me, dude. So is this, I mean, this looks like C++, but I assume this is Rust, right? Is this is a lambda, right? A lambda of UI. And then he's renaming UI in here. That's a smell. Okay, let's start there. It's not a smell. Yes, it is. Yes, it fucking is. This looks like very inefficient code, but whatever. It's UI. It doesn't need to be that efficient. Okay. Almost every layout operation is a closure. Yeah, it would be nice if we could reduce the nesting and move the if outside. I mean, I actually have an idea about how to fix this problem. I think this is fixable, but I'm not going to say it because I don't want Rust people to steal my ideas. But it would increase compile time, so you probably don't want to do it because Rust is already horrible compile time wise. But this is actually solvable. Actually. And I'm not sure why they haven't done it. It's pretty weird, honestly. Okay. maybe there actually is a reason why it wouldn't work, but I think you could solve this problem that he's talking about. And I think that would make Rust a lot more permissive, honestly. It would involve expanding the type system a little bit. All right. In-game UI. I wouldn't try to use a UI library for in-game UI. I mean, I guess he did. I mean, it depends. If it's a game like Factorio where there's a lot of 2D stuff in an overlay, then maybe you could use a UI library for that, but I still wouldn't. Probably. What is reactive UI? What does that mean? It means it resizes when you resize the screen. It gets angry every time you click on it. Declarative. Immediate mode. Everybody's saying something different, and they all conflict. All of your answers all conflict. Fits multiple device type. It's like React, basically. But what does it mean? UI that adapts to screen window size. I mean, you mean like video games since the 1980s? All right. UI that reacts to changes in data. Dude, I've gotten like 9 different answers to this question. I think it's when a function calls itself. Wow. That's clearly the best answer. Let's see what Wikipedia says. We all know that Wikipedia is right about everything, especially politics. Reactive. Users immediately aware of the effect of each gesture. Okay. Even saying gesture makes me think it's not reactive, but all right. Because most gesture UIs are not very reactive. The user is always aware of the state of their data. Okay, the user always knows how to get... Okay, what the fuck? All right, this section can probably be quite short. Orphan rule. What is the orphan rule? Most safety. A desire for perfection and complete avoidance of all problems at all costs, even if it means... So what is the orphan rule? I'm a non-Rust programmer and I don't know. Okay, we have to look what this is. Rust orphan rule. Allows writing a trait impl only if either your crate defines the trait or defines one of the types the impl is for. If your code uses a type defined outside your crate without a Serde impl, you resort to new type wrappers. What? This is all just like object-oriented nonsense to begin with, I think. Right? Is this the wrong answer also? You can't, no, it says it's right. You cannot provide implementations for a trait or struct unless you are either the crate that defines the struct or the crate that defines the trait. Yeah. Yeah, that's ass. All right. Great. Kind of like what poke name is. No, because poke name's a little different. I think. Because, you could add the equivalent of a method, which in our language is just a function. You could add that into your own namespace and nobody cares, even if it's an overload with all the normal functions that apply to that data structure. So there's like literally no problem, right? If you want to put it in the namespace of a module, yes, that's kind of what poke name does. We're probably going to get rid of poke name and do it a different way anyway. But we'll see. Like it probably should just be inserting your declaration at some scope, and you have a way to name that scope. You know what I mean? And then you don't need a separate directive for this. And then you could put a string there and it's fine, right? That is something I would like to clean up, though, is get rid of poke name. Because Pokemon didn't pay me royalties anymore. The royalties ran out, so we got to get rid of the directive. Okay, compile times have improved, but not with proc macros. Okay, I'm looking for concrete times. So incremental builds take 10 seconds, is what he's saying. Yeah, that's if it's like 1,600 lines of, I guess he's saying this is generated code from the macros, and it's 8 seconds for 1,600 lines of code. That's insane, right? That's very slow. On a modern computer, that's nuts. All right. Game dev ecosystem lives on hype. Whichever project can make the most amount of promises. Yeah, I mean, this is not unique to Rust. This is like the programmer enthusiast community, broadly speaking. There's very little independent critical thinking, right? It's about advertising your thing. And it's part of why we're in the hole that we're in these days, right? I think maybe this is more amplified in Rust because Rust itself attracts that kind of personality, because Rust itself is about, the journeying to the promised land. I don't know. All right, macro quad. I don't know what that is, but it's a very practical 2D game library, apparently. Macro quad uses global state. Oh my God. All right. Yeah, if they insist on everyone using a new thing for everything, that's not great. The sacred crab code. Okay. Ouch. Wait! I thought Rust solved all your bugs. Why is convex decomposition crashing? I thought it's impossible to crash in Rust. Why are multi-body joints causing it? What? It's impossible. Rust is memory safe. You can't crash. Not sure anyone's ever said that. They say it all the time. Rust people overclaim so much. Like, not the main Rust people, but random enthusiasts. They always say stuff like, I'm just very happy to know that if it compiles, my code is correct, right? Which is complete nonsense. Complete nonsense. I censored myself from saying worse words there. People say that. They've like propagandized themselves into that. That's a pretty fair statement most of the time. No, it isn't. Not for complex programs. The only people who think that are writing relatively simple programs. All right. Because again, most bugs are not about who owns what memory or data, right? Most bugs are just like, there's a logic error somewhere because I was confused about what should be happening when I programmed it. That's literally 98% of bugs in a complex program. All right. I'm going to get a drink. I'll be right back, and we will continue to read Global State is Annoying. I got my tea. I got pistachio nuts with regular salt. They sell these salted and lightly salted, but I want the heavily salted option, and that is not available. I've got peppermint honey that I'm just going to eat some of, and I've got the rest of my supplements. When I got up, it's not even noon. Oh, it just ticked over to noon as I was saying that. Like my body felt cold, right? Like my body's down regulating from me not moving. So it's probably a good idea to get up a little more than I have, even though it makes little interruptions in the stream. Do I have salt? Yeah, but it's not like gonna stick, right? Maybe it would. I don't know. What kind of supplements? A lot of things. A couple of them are multivitamins that have tons of stuff, right? But yeah, I think I found the right combination. So one of my theories about, there's a lot of reasons why people might be getting fat. And one of them is, poisons in the environment, which I think is a contributor. But one of them is just maybe food doesn't, in fact, it's known that food doesn't have the same density of nutrients that it used to have, right? And so maybe part of it is your body legitimately saying like, look, I'm not getting enough of something that we don't understand very well. So you better eat more until we get enough of it, right? And that could be part of why so many people are fat and why they're fatter when people eat processed foods, right? But even people who go to shop at Whole Foods and whatever are just like fat all the time now. So I started experimenting a while back, just randomly trying vitamins all the time, like different ones, to try to figure out what was the missing nutrients. And sometime in December, I was trying this and I was like, hey, wait, I wasn't really that hungry today at all. That's weird. And so I just stayed on that combo, and I've been on that for like 3.5 weeks. And I've dropped since probably December 15. I don't know. I can't tell you the exact day. But so, that's like 3 weeks ago. I'm like 10 pounds down from where I was. And I'm eating tons of sugar and all sorts of stuff, right? So maybe we'll keep monitoring the situation, and if it continues to work, then I'm very happy. I will post the stack. If I get under 200 pounds on this, I will post the stack. Because that'll be a total loss of more than 10% of body weight, because I was getting pretty chubbed up. I was like 227, and now I'm 216. So that's going pretty without in fact, I was injured the whole time too. So I've been doing literally no exercise. I've been eating tons of sugar and whatever, and I'm just losing weight. So it's great. How tall am I? 6 feet. Europeans don't know how tall that is, but I'm 6 feet. 1.87 meters or whatever that comes out to. 2 meter, no. 2 meter is more than 6 feet. Yeah, so I was getting kind of chubbed up. Metformin, resveratrol, NMN, no. One of the multivitamins I think has a little bit of NMN in it, but I think that's incidental. Okay. Yeah, the harmful and unpractical rules is one of the things that I object to, right? They're religious rules, which again are motivated by something real and a real problem, but they're carried way past the point of actually being beneficial, right? Okay. Um, but yeah, I'm pretty happy. So I've been like 216 the past couple of days, which is what weight I was when I first moved here 2 years ago, and then I just chubbed up even more since I've been living here in Boulder. So which is weird because Boulder is supposed to be like the thinnest city in the U.S. And I chubbed up by an extra 12 pounds when I moved here, but we're back down. So we're back down to 2 years ago. So we just have to keep going back down, right? Continuing the train. $242 down from 286. Congratulations. I mean, dude, losing 45 pounds. That's a lot. I'm glad you found something that's working. I will not take stomach paralysis juice. I refuse. Am I a Colorado native? No, I'm a California native. Yeah. The thing is, I'm taking all these supplements, and I'll post them if it continues to work. But like, it might not even be the supplements. It might be that I mostly got off seed oils 2 years ago. And there's a graph somewhere of. Let's see if we could pull up the graph. No, I'm trying to search for it, and I don't see one. Maybe someone could find it, but there's basically a graph of like how long seed oils stay in the body, and like what the if you stop dead cold, there's like a falling off function that kind of looks like 1/x, where it actually takes a while for seed oil levels to get low. Um, and so 2 years might be past the knee of that curve or something. What are seed oils? Google it. All right. Just by saying global state immediately triggering many people. Yeah. Global state is fine. Again, there are problems. Every problem has a certain natural amount of global state, which may be zero for, like, if your problem is to compute factorial and it's not a factorial of a very high number, the natural amount of global state there is very low, right? Zero, probably. But keep in mind, there's already a difference. Like, you might compile in factorials for some numbers just to accelerate the computation, right? And so you might have read-only global state, which is not really what they're talking about, right? When people say global state, they really mean things that could be modified at runtime, right? And so keep that in mind. Anyway, I will tell you every problem has a natural amount of global state. For some problems, that amount is zero, like the functional language and Rust people really want. But for a lot of problems, the amount of global state is naturally more than that. And for a video game, the amount of global state that's natural is huge. And if you say, "Oh, I didn't make a global variable, I made a singleton," a singleton is just a global variable. Like, get the fuck off your stupid horse, right? Um, so so yes, uh, incorrect amounts of global state will make your program messy. If you have a lot of natural global state, bad management of that can be a problem. Yes, it can cause bugs. But pretending like there shouldn't be any is also stupid. It'll also make your program too complicated, and it'll affect your engineering ability. Because here's the problem. A good engineer needs to have clear eyes on reality, right? He needs to be doing, or she needs to be doing, a very clear cost benefit analysis at any given time, right? And if you get into the real danger of this stuff is not exactly that you have the wrong opinion about how much global state there is or whatever. It's that you get into, like, propaganda victims get into this realm. You know, we know this from history, from politics, right? They get into this realm where they're lying to themselves all the time to maintain the propaganda, right? Like, oh, my program, yeah, it sure was a lot of work to avoid having that global state, but my program's so much better because I did all this extra work, right? You start lying to yourself as opposed to observing what actually happened. And that's the problem, because as soon as you start doing that, you're not doing good engineering anymore. And that's just the downfall of everything. Like, it's just very hard to be a good programmer when you're lying to yourself all the time about these things. And you have to unlearn it. Like, I went to college, I learned certain things about programming languages and how they should be, and I had to unlearn all that stuff. And I was lying to myself about that stuff for the first several years that I was a professional game programmer. It's just, it's inherent to programming culture that we get propagandized, right? So, and you see it in different, like the object-oriented people are like so sure that you're an idiot if you don't use object-oriented programming, right? And it's like everybody else looks at that and they're like, what are you talking about, right? But it only makes sense if you're like deep into the cult. So yeah, it is what it is. OOP isn't in vogue anymore. I know. That's what makes it easier to make that comment. If I had made that comment 15 years ago, most people would be like, what are you talking about? What do you mean? You're stupid. You just don't understand OOP. You don't get it, right? And it's like, actually, I get it, guys. I've done it. It sucks. Observing actual reality is a big problem. In my experience, people tend to be afraid of global state because they do not know the requirements and play what-if games. Yeah. Well, but also, I mean, here's the thing. It is true that programming is hard, and when we go to solve a problem, we're following some heuristics that we learned about how to be good programmers. And the problem is the people who teach us, which used to be all universities, but now I guess is more and more just opinionated articles on the internet or whatever. The people who teach us are not very reality-based about what they teach us. And so we have to unlearn so much of it, just like we have to unlearn the equation of a line, right? It's the same thing. Okay. Yeah, microservices was definitely the trend of some years. Although I saw even on Hacker News the other month an article that was like, oh man, microservices was such a bad idea. So even, you know, that trend is starting to be like, isn't this a giant waste of time? Like, we even mentioned the JavaScript game tools thing earlier. Isn't this a giant waste of time to keep doing this thing where we introduce a new cool idea that's supposed to solve everything, but it's not very reality based, and then everybody buys into the hype and wastes a tremendous amount of time and energy for 5 to 12 years. And then after it's over, everyone's like, oh God, glad that's over, right? And that whole time, all that time and energy could have been spent actually making forward progress in the world of computers, but wasn't. Like, haven't we done that enough? You know what I mean? Like, how many times are we going to do that? But that's what this marketing oriented culture is like, right? It's weird because programmers think like, oh, I'm not a marketing guy, I'm a technical guy. But all these technical people spend all their time marketing their thing to other programmers. Like, just fucking chill and make the best. That's why I haven't released the programming language I've been working on for frickin' 12 years now. Right? It will get released eventually, but I'm trying to like actually make it good instead of just releasing something and hyping it. Because that's what I see literally everyone else do. Ads work. I know, but like we've just done it so many times. Like, when are we going to learn? It's like the end of War Games, if everybody here is too young to even know what that movie is, where it's like simulating out all the nuclear first strike scenarios. And Professor Falcon is like, come on, learn, learn. It's exactly like that. That's what the software community's been doing. We're just trying all the nuclear first strike scenarios, and all of them end in everybody on Earth dying, right? Okay. Anyway, yeah, he's just saying, look, there's just some global state. He's talking about Bevy again. So Bevy is an ECS library or crate or whatever the hell. Yeah, I've looked at the homepage for Bevy, and it just doesn't look like it's trying to solve anything that I think is a real problem. It's one of these trendy things where it's like, oh, ECS is cool. We're going to make an ECS game engine. And it's like, dude, that's just not the issue, man. Play sound beep. That's exactly right. Sometimes you might want a handle instead of a string because you want it to be preloaded in an asset pack. But like, yeah, no, this is the right thing. Or maybe you want to add a position and a volume and panning and stuff, and you can do that here. But like, yes, you don't want to do anything more complicated to play sounds. Yes, it's same. This is what we do. We call it something else, but yeah. Yeah, I mean, that's what you want. Oh, God. Oh, no wonder it's horrendously complicated and nobody uses it. Yeah, parallelism is hard. I mean, this is the problem is the Rust people say, hey, we have fearless concurrency, right? But the problem is the fearlessness also makes it not concurrent because everything's waiting on everything else. So like, well, and again, I've said this ever since way back. Concurrency is a weasel word, right? What you actually want is parallelism. Concurrency means these things are not ordered with respect to each other, and parallelism means we're actually using the hardware at the same time. And the problem is if concurrency is not carefully hand designed, it becomes weasel concurrency. I need to coin that phrase, weasel concurrency. It becomes weasel concurrency because everything's sleeping on the result of something else waiting to be computed, as opposed to parallelism, right? So that's the problem that you run into. And that's another thing that I think Rust people haven't admitted to themselves yet. Is like, yes, it's good to have these constructs in some ways because it's good to not have to worry about data races and all that. That's great. But like, if the restrictions are so tight that it's very hard to actually achieve parallelism unless your problem is embarrassingly parallel to begin with. And that's the problem is some of these things like grep, I argued on Hacker News one time with grep guy. And he was like, oh, it's so easy to get parallelism. And I'm like, you're just grabbing a bunch of files. That's automatically parallel. Like, try a real problem, you know? Um, yeah. So, I don't know, man. Um, I mean, again, though, this is not to bag on the language in a we're not trying to do language wars. Like, again, it's motivated by a real thing. Like, it is true. Dealing with threads accessing data is really hard. And you really could use some help or some guardrails there. If I could figure out a different set of guardrails from what Rust does that still really helps, I would implement them. But I've never been able to figure anything else out. When I look at the very specific things that we do in the compiler and in the game to do things in parallel, I don't really see anything that would help except the only thing that I would think of is to go back to an architecture like Go has, but change it a little bit. So Go has this thing where it's like, you start a Go routine and you send messages to it, and I believe all the messages get copied. And that's a very safety-oriented thing. In reality, you don't want to copy all those messages, right? So you really just want to send pointers in a command buffer or something, right? For a highly performant system. But like designing around communicating with threads between command buffers is sort of the architecture that feels right to me for the future. The problem is just that still says nothing about making sure you don't have data races and stuff, right? I mean, Go is preventing data races by saying like, look, the data is all copied. You can't have a data race. But in a real system with a lot of data, you can't copy the data. So you have to do some. I mean, you could say it's read only. So in the case of something like a renderer, you're sending a bunch of data that's read only anyway. And so you could kind of do a copy on write thing, but even that's very expensive and confusing. I don't know. But like you would have to start thinking in that direction, I think, right? Like a command buffer architecture makes sense. Casey and I have talked about this. I think if either of us were to design a new operating system, it would be command buffer architecture for everything. Like there wouldn't, like to talk over the network, you would do a handshake to get a command buffer endpoint, and then you would just send commands in the command buffer. There wouldn't be like API calls. You might have the API calls as a convenience on top of the commands, but the commands would be the core truth of the interaction, and then that would let you innovate on API, right? Go interfaces are two-word. When they're stored in a location, two or more Go routines concurrently modifying it can observe torn state. Yeah, okay, well, that's a bummer. Don't do that. But that's still just like a subset. Okay, here's the thing is you can complain that Go has that problem. But like they were still thinking about it and trying to solve a bunch of problems. You can't really complain that they didn't solve every problem. Because nobody has solved every problem. Is there a video on YouTube of this discussion with Casey? No, I think it was a private conversation. Okay. Have I seen the GDC talk about CD Projekt's job system? No, but I'm probably not interested given what a fucking clusterfuck Cyberpunk was, and then they threw away their game engine after that. I don't think job systems... There was like an Insomniac talk, or again, one of Naughty Dog or somebody, about their job system, and some of our programmers did it, a simpler version of it way back, and like, there's no point. It's like entity update code is cheap. It's all rendering. Like rendering is the expensive thing, and you don't need a job system for that. So like, what are you guys fucking around with job systems and dependency management and all? It just doesn't make any sense. Cyberpunk loading code is so bad. Oh, I guess you have observed the data access patterns is what you're saying, and you don't like them. Is it as bad as the Grand Theft Auto online thing that everybody complained about? Okay. Yeah, weasel concurrency is my new term that I am coining today. Maybe there's a better term for it, but what am I doing in terms of water rendering? Well, nothing right now because we haven't gotten through the article. Okay, Bevy, whatever. I'm never going to like Bevy. I don't think it's interesting, so we're skipping that, the rest of that. Unexpected crashes after refactoring. Oh, dynamic borrow checking. Okay, because this is the solution. Even a Rust enthusiast in chat here said to just change to dynamic borrow checking. All right, so I don't know anything about dynamic borrow checking. I didn't even know it was a thing. So let's see. An overlapping world query Okay, so I guess dynamic borrow checking is going to crash your program if you violate the borrow checking, right? Is that how it works? Yeah, that sounds like hell. Sounds like hell. Yeah. Context objects. I don't know what a context object is. Just store the references to whatever you need for later. What if I just use the lifetimes? Blah, blah, blah. Problem is, what if we now want a fun... I thought... Okay, wait. Wait. I thought Rust had implicit lifetimes forever now. I thought if you do this, you didn't have to put A here. Is that true? Or do you still have to put A there? I thought this would get inferred to be this. You still do. Really? When I know that sometime like 8 years ago or 10 years ago, they were like, oh my God, we've revolutionized Rust because we figured out how to do implicit lifetimes on a lot of things. But that doesn't work here. Auto lifetimes are for functions. Okay. Sad. All right. Let's keep going. Problem is, what if we now want a fun-fu t thing? Of course, we can't. Thing is generic over a lifetime. Right. So this has to. You have to put the lifetime. Yeah. I mean, that's Rust, right? If we want to store a thing in another struct, potato has to have. Yeah. So basically, what he's saying is lifetimes propagate outward anytime you want to use something. Just like const in C++, actually, right? If you're familiar with that. Like, once you start using const, it pollutes anything else that uses it. Okay. It does not allow unused lifetimes. Oh my God, are you serious? That's trash, dude. So you have to take this out, and then you have to take it out of anyone that uses it? Oh my God, that's trash. So this does not seem like a technical constraint at all. This just seems like someone being a bitch, honestly. Seems like someone who's like got the correctness stick shoved all the way up their nose. This means you couldn't even have an if-def equivalent. I don't know how Rust does that, but like, what if you have an if-def that in some build configurations this member exists and in other ones it doesn't? Does that just, I have to redefine all of foo? Are you kidding me? Because there's no correctness reason to not allow this as far as I could see. That's just an arbitrary decision someone made. All right. Just pass a global state ref into everything. I mean, that's counter to the spirit of Rust, isn't it? Okay, one alternative that Rust provides here is shared ownership. I mean, the problem is, again, this is the thing that happened in that ECS video too, is like people praise the borrow checker for making them do things that dodge the borrow checker. And it's like, wait, what? I mean, if the borrow checker is really so awesome, shouldn't you want everything to be maximally under the purview of the borrow checker? Why are you doing all this stuff to structure data so that it's not checked? What? Right? Like it's this very weird Stockholm syndrome where you're like, it's awesome that my kidnappers beat me when I try to go outside because, I don't even know. I don't know where this analogy is going. It's not connecting. Never mind. But it's something like that. It's like, the borrow checker beats me for trying to go outside. So instead, I stay in this tent that's attached to a hole in the house. And so I'm not inside, but I'm also not outside. It's like that's what all this is. I don't know. Okay. Yeah. So this is what we do, sort of. I mean, in a different way. When did they start doing this? Is this copied from our stuff? Or like did it predate? Cuz like calling it context with a capital C is sus. That's the only thing that makes me think that. Because I don't know, we started demoing that like 10 or 12 years ago or something, so it's plausible. It's user level. I know. But I'm saying, like, when did this convention start getting adopted? You think Go did it first? Okay. All right. Cool. Every function in your game can just accept a simple context and it gets don't end up borrowing anything. Yeah. All right. Positives of Rust. Oh, we're getting toward the end of the article. It often kind of just works. Okay. This is better than saying it works. I still don't buy it to the extent that he's saying it, but yeah. Performance by default, I mean, that's sort of true for any language in this class, right? C# is a garbage collected language. Rust is not. So, yeah, that's good. Especially given software is so slow these days. Performance by default is a good idea. Enums. I don't think enums are very important. Is Rust one of the languages that let you have like strings as enums and stuff like that? I don't feel like that's that important. Or do you think he's just referring to the pattern matching deconstruction stuff? Yeah. Enums and pattern matching, maybe? Enums are tag unions. Okay. Yeah. So that's something we don't do right now. It might be a feature that we add eventually, but it's like, it's just not important enough, I feel, to pollute the language right now. There's just other higher priorities. Rust Analyzer. Rust Analyzer tends to crash and not work. I thought Rust meant you can't crash because there's memory safety. What's going on? All right. It even has Rust in the name. How can it crash? What are you talking about? It's impossible. Someone call the White House. Now I understand why Primeagen and stuff does React content, because this is our first React content we've done in a long time. We have more viewers than usual, so... All right, this is now a React channel. I'm not going to program anymore. It's just React content. I'm going to watch Primeagen videos and react to them. All right. So what do we got here? Laravel. Oh, Laravel.
All right. So I literally know nothing about Laravel.
Neither do I. All right. So did you guys ever see the thing where like Shroud and somebody else were having a React battle where they kept reacting to the other guy's thing? I forget who the other guy was. And they got like 7 or 8 nested deep. All right. Dr. Disrespect. Yeah, it might have been Doc. Back in the days when Doc was not canceled. Okay. Does Doc still stream now? I never see a video come up in my feed. Yeah, he posted a 2024 recap 4 days ago. All right. He still streams. Interview with senior JS developer. Yeah, I think I've seen that. All right. I mean, if you haven't ever made games, it's just very hard to describe the incredible complexity involved. It's really hard to make games, guys. And so, I mean, if anything, this is an oversimplification of what this dude's been doing. It's complicated. Macro quad. Unrelaxing quacks. I mean, I get it if the whole thing is like, hey, we were on C sharp, but like this isn't that many enemies. I mean, like I said, we made games 22 years ago where you had 100,000 enemies. So, I mean, hopefully the page is still up. This was in 2002, I think. Oh no! The page is down. Can we get the archive now? Or did Google get rid of that? Um, let's try to Wayback Machine this. Does Wayback Machine still work?
All right, so
No, wait, what happened there? I accidentally activated a history or something. All right. I mean, it hasn't probably changed in forever, so. All right, so the point here is, hey, that's me in the back. What resolution of image? That's me in front of the whiteboard. I didn't actually work on any of the games because I was working on a GEC speech, but I was working on I worked on the engine a little bit. Okay. Who is here? Let me tell you who is here. I think that's Sean Barrett. It's a very blurry photo. Sean Barrett, Doug Church, who worked at Looking Glass and has gone on to do many things. Brian Sharp, who is maybe still at Oculus. I think this is Chris Carollo, who's at Valve. Art Min, who I don't know where he is. Brian Jacobson, who I think is at Valve. Ken Demarest, who he's not in games anymore. Thatcher Ulrich, who went to do Google Earth, and then I don't know. Who's that? Oh, that's is that Austin Grossman, who went on to be a fiction writer? It might be Austin. I don't know. It's very blurry and indistinct. Chris Hecker is probably taking the picture. This was at the Indie Game Barn where I had an office and stuff. Charles Bloom on the left, who worked at Oddworld and then went to Rad Game Tools and was one of the chief people behind Oodle, which is now the compressor built into PlayStation 4 and 5. Or is it just PS5? I don't know, dude. Anyway, and this is, oh God, I'm blanking on the dude's name. I'm sorry. I forget. This is Zach Simpson, I think. Right? When I search on the web, I get a different Zach Simpson. Hold on. Yeah. So this dude did this early shadow garden stuff that would be in museums where like it would, you see this kind of thing in malls now and whatever, but he was doing it back before anyone was doing it. He was doing it in like 1998 or whatever. So that was pretty cool. So yeah, this is like, the game industry would be really different if a bomb had gone off in this room at that time. There's a list of names just below the... Oh, okay. Well, I'm telling you from memory, man. All right, so let's go back and see. Casey. Okay, he said Austin. I didn't see Mark. Mark LeBlanc. Okay, can I like get this photo open in another page? Is that... Okay. I don't see Mark LeBlanc here. Um, yeah, I don't see him. So maybe he's out at this time. Oh, Robin Walker. He maybe wasn't in the photo. Robin Walker is Team Fortress 2 guy. There's a lot of Valve people in this photo. Justin Hall is also not in this photo. All right. So on Pentium 4 computers, we made a bunch of games, and the goal of the games was to have 100,000 guys was the theme of the thing. And so you had this terrain landscape. I mean, it's year 2001 graphics or whatever, right? But like, you know, we had these games where Wayback Machine is not fast, but like 24, 23 years ago, this is how many dudes we had at once, all right? And this is running at, this is Chris's frame counter. Each bar is like either 5 or 10. I don't remember. This is either running at 40 FPS or 80 FPS, right? But the point being, it ran at totally real time, whatever, with 100,000 enemies. So like, and that was 20 years ago. Do you have any idea how many enemies you could have now? Did it say 256 megs? Probably. Like that's probably about what you could have now. What? Dude, I'm control clicking on the photo and it keeps, what is wrong with Wayback Machine? It doesn't respect my control click. Let's see. Maybe it wasn't on this page. Did we say RAM? Frames. Previous page? Yeah, I don't have a game in this stream. I ended up, it was so stupid. Because this always happened around GDC time and I ended up doing GDC stuff every year. If I were to have it over, I would just fucking do this instead of GDC stuff. It would have been much better to do this. Yeah, 256 RAM. GeForce 4. No, that's literally the RAM on the computer, okay? That was a lot of RAM back then. It was a lot of RAM. But that's the point, is like, we were doing 100,000 guys so long ago. You could do, I mean, I don't know. I almost said 100 million guys. You might not be able to do that. But 10 million or more easily? I don't know. It depends. Chrome doesn't allow opening HTTP sites. Okay. All right. Anyway, you can go here if you want and check out the games. They were very creative game ideas and it was fun. Yeah, Dueling Machine is multiplayer. Now that I think about it, Chris's game Spy Party is a Dueling Machine clone. What the fuck? What was my job? I was just like an indie game dude who just hung out making whatever I was working on. All right. So there you go. That was the game industry back when it was good. So like I look at this and I'm like, that's not that many dudes. You know where I'm coming from? All right. But it's fine. It's just part of how software is so sad now. Like we have computers that are, you know, hundreds or thousands of times faster than what we had in those days, and we still think this is like a lot of stuff for them to do. It doesn't make any sense. that's how low software has fallen. How did I make money being an indie guy? Contract work. Yeah, it was contract work mostly. Um, I mean, I wrote the technical column for Game Developer magazine around that time, but that paid $800 a month. Of course, $800 a month was more money back then. All right. So what have we learned here? I mean, I don't know. I just I learned some nuance about how this particular person views it. This author's, there's no name on it anywhere. This author's, unless it's the bottom, this author's opinions mostly seem to coincide with mine, except they're more tempered by the reality of actually having done it, right? Like I've never programmed anything significant in Rust. I've looked at it and said, it's not my thing. I'll program over here. But this is, by someone who has actually done it. So there you go. A technical achievement in the loose sense that it does anything at all using JavaScript. Yeah. How can you handle 10 million guys? No, it was 100,000. It was 100,000 guys. So you're off by 3 orders of magnitude. Yeah, we had easily a lot of bytes per guy. Memory wasn't the problem. CPU was the problem. And so the system was a sort of a thing where all the guys would have their velocity vectors set, right? And they would have behavior and they wouldn't update every frame. Sean Barrett wrote this part. You could actually ask him, does Sean still stream? I mean, I know I played Helldivers with him a way back, but, so you wouldn't run gameplay logic for all the guys every frame because that's like slow if statements or whatever. But your particular game could decide how often to tick different subsets of objects, right? And so when you tick them, you would like reset the velocity vectors or decide to change the color and whatever. Yeah, these days CPU is free. Have I seen Tiny Glade? Yeah, I played it. It's not much of a game, but it's cute. Like it's more like a cool 3D modeling tool that models a very specific small set of things than a game. But that's fine. It's a reasonably complex program. It's not like Elden Ring. Like Elden Ring is 100 times more complicated. But, it's fine. It's cool. Did I ever find having a steady full-time job boring or not interesting? Yeah, I was a bad full-time employee. I would get demotivated at full-time jobs after a while and have problems. Did I learn a lot as a full-time employee? Not that much because I had been self-taught before I went full-time. Well, no, okay. Just out of college, I had full-time at some enterprise software company, but it was a small outfit where I was sort of determining what I did anyway. So I didn't learn that much that you wouldn't learn just from practicing your own programming for 6 or 8 months. Then I was a contractor porting Doom and stuff, and I learned a lot from the Doom code base and all that, but not really from the team. Half the team got poached by Netscape halfway through that. And then I went off on my own for several years, and I only did a little bit of stuff at full-time companies after that. So my most intensive learning was really on my own. Could I have learned stuff from full-time companies? Probably, but it would have had to have been the right place. You heard that Japanese game developers deleting their source code after release was a thing? I never heard that one. That sounds like a huge mistake. Nobody would do that now. I mean, back in the day, it was not that uncommon to restart from a new code base every time. But now I wouldn't do it. How did I get the contracting gigs? Especially with limited experience. I mean, the game industry was a lot newer back then. And I spent my first several years in the game industry writing my own 3D engine. And there's very few people even back then who would do that. And so if you wrote your own 3D engine and shipped a game, that's all the experience anyone would ever want for the entire history of the games industry. So you're just qualified, right? Now, it turns out there's other skills that I wasn't as good at. Like when you're a contractor, like understanding what your client really wants and what's the best thing to do in this context and how to work with people most effectively when you're a temporary member of the team and you don't have buy-in and trust from them necessarily. These are all skills that like I wish I had known before doing it and had to learn the hard way and still hadn't even fully learned by the time I stopped being a contractor. But like the technical part, I was one of the most experienced people in the industry at that time. Like that photo that you saw of Indie Game Jam 0, I mean, that was sort of curated among the people who Chris was friends with, but those tended to be forward-thinking programmers who were doing interesting stuff in the games industry at the time, right? So like, you kind of knew everyone who was in that group, you know? As of today, where does my income come from? It's from the games that we made and published. The hardest thing you struggle as contractor with is holding your tongue. Yeah, I contracted for an indie game developer who you all would know. I probably told this story before, but you all would know this developer. And this was while I was working on Braid. I ran out of money in the middle and I was like, oh, okay, I'm going to work on this for months. And it took, for their relatively small, cute game, it took like 45 minutes to compile. And I was like, the way you guys are doing this is really deeply wrong. And this should be a lot less code and should be trivial. It was in C++. And they didn't want to hear it because I wasn't trying to do it in a personally attacking way, but I was essentially dissing their lead programmer and tech lead at the company who wanted to do things in this very C++, like not just very C++, but very extremely weird dogmatic way. It was kind of like MFC. You know how in MFC, if you even want to make a button with a different text on it, you have to subclass it if you're doing things the way it was intended? It was like that. It was nuts. It was not Oddworld, no. It was a much smaller company than Oddworld. But yeah, I mean, maybe I could have been more politic in there, but I was just very blunt. Like, guys, this is stupid and it's costing you a tremendous amount. How do you even achieve a 40? Dude, I worked on several games that had 45-minute compile times. Deus Ex Invisible War, when I worked on that, was about 45 minutes to make. If you changed like any script variable at all, like it's so ironic because you think the reason to use a scripting language is so you can hot load it and be fast. But back then, the script variables generated header files that were included globally in the game. So if you affected any script, 45-minute recompile of the Unreal Engine. It was real bad. It was real bad. Generating header files for scripts, yeah, because you had to have interoperability with the C++, right? So, like, because the script isn't magic, right? It has to call into functions in C++ to actually do things in the engine. That's how it always works, right? So if you made a new data structure for like some cool thing that you were doing in the gameplay code, the C++ probably needs to know about that data structure. And the way this was done, it maybe could have been done in a more hygienic way, but the way it was done at that time was literally the whole engine would recompile. Okay. How happy was I when Braid succeeded? Kind of happy sometimes, but actually it was much more of a negative experience than a positive experience. I mean, it helped put me where I am today, which is great. But like, it actually kind of sucks to release a game no matter what, and then to like have the reaction to the game be like such a shitburger dog pile like it was. I hated it. Um, and that was a positively thought of game, right? Uh, all right. Um, all right. We're gonna do water stuff because we're done with our React content. Dude, we almost got 1,600 viewers with our React content. So now we're gonna do some very boring programming. I need another drink from the fridge, but before we do that, we're gonna start the game and make sure it works and stuff. And we're gonna put up a good looking level for a minute so that people think the game is good, and then we'll go back to our programmer level and work on water. The first thing I'm going to do, well, we'll talk about it as we do it, but we're going to be going back to this level in a minute and working on the water to make it look cooler. But I'll be back in a minute. Let's go to good looking level. Because we've been on Christmas vacation, I don't think there's new levels finished yet, so we're going to go to the same old levels. We're going to go to this baller fucking level right here. All right. I know many of you have seen this. It's our screenshot while I take a break. Back in a minute. Is Distant Lands the definite name? No. No, it is just better than Sokoban, right? Which is what it was called for a while. I have a candidate for the actual name. But the candidate is a longer name that would take 2 lines to display here, and so I've been too lazy to program in a second title line on the main menu, so I haven't changed it. What happened to Heroes of Sokoban? That's just not the name of the game. And nobody knows what the hell Sokoban is. What the hell does Sokoban mean? Unless you live in Japan and then you think it's a game about working in a warehouse. Like, it literally doesn't mean the right thing to anybody. Okay, back in a minute. I wanted to have a spiced apple. Dude, check it out. Wait, I got to do it fast. Look. Look. 1541 viewers. Do you all know the significance of that number? Being a computer person is like being Ramanujan. It's like for any integer, you know profound meanings of the number. 1541. Now it's down. Was the model number of the hard drive, or the floppy drive, sorry, that you got with the Commodore 64. And this was a cool thing because it could also play music by vibrating the drive heads. It had an entire other 6502 CPU in it, as powerful as the one in the main computer. This was the second generation. Why did they use the number 1541? I have literally no idea why they thought that was a good number. All right. Okay. Let me show you something if I can figure out the UI again. So we're working on water. We sort of have re-implemented it because we need to get it finalized and out of the way. I'm going to get rid of some of this stuff. These little foam puffs look bad, and we're probably going to work on that later too. But first, I'm just going to make this less ugly because it's not what we're working on. First, let me show you a cool feature that I did, I don't know, a couple weeks ago. Small thing, but we have this thing called vertex paint in the game, right? Where you can paint. There's a specific set of quote unquote color channels on the meshes that you can paint to blend between materials. And this is a general technique that, I don't know, it got popularized in games around like Uncharted 2 timeframe or something. It's how they did terrains. But it's a very easy technique, right? And so, where's paint? Paint. So if I pull this up, I got to remember the UI. I need to remember the UI to probably test things eventually. Wait. All right, we got to go to the key map. Sokoban, run tree data, developer, paint, manip paint. Oh, it's T and control T. Okay, I thought it was L for some reason. Paint ground. No, T. Okay, here we go. So, oh wait, that's not painting the water. Oh no, it is. Okay. So what we're painting right now is several channels, but that includes like water opacity, which is in one of the channels, and I don't remember. So the different channels have different values, right? But I did the alpha channel lately, and what this does is there's a little grid pattern that's procedurally generated. Let me, can I turn this up? Can I go like strength 10 and radius 2? This might be overkill. Yeah, oh, check it out. So I can sort of paint the existence of this grid pattern, like where we want it. So if you're like, oh, you know, between, like maybe you need to skip a stone across here. So we want some gridding like there that you could read, but we don't want it like, you know, we want it to feel organic and like not super solid, right? Etc. Okay. And notice how, like, as I paint it really deep, notice how it's like affecting the heights of the waves and stuff, which was a fun thing that I did. So if you really get like hard grid, now it's not that readable as much as it should be because I was still experimenting with it and doing like procedural noise and stuff, right? The yellow paint. No, not the yellow paint. Um, but you know, the point is you wouldn't use it totally like this. It's like we want it to be more organic and just where it's needed, but to help you read the level, right? Okay. So that's something the artist people can play with. But the point is, like, look how cool that looks, man. And this is the programmer art, so the artist art will look better. So this, how am I deciding when I make the wave heights higher? How do I know when we're on a grid and when not? And the answer is, it's just some function that I can show you right now. It's just math where we're saying like, you know, what is the fract of our number minus something, right? And whatever. And using that to detect when we're near the edges, let's do, this will be educational. And it'll remind me of what I did. Shaders, materials, ocean D. Okay, this is our own shader language, but it's not because I want to do that, but it's basically GLSL, but better. All right, so grid, this is a bunch of variables. Hey, look, it's global state that Rust won't let you have. Oh, gee, the entire future of programming on massively parallel machines is all these shaders that have global state. Oops. Oh, good thing they're doing WebGL or whatever that has the Rust vec to less than float greater than. That's so great. At least we could put a crab emoji in our source code. All right. So I guess I'm doing a different function. I guess I copy pasted it because I wanted to edit it some. So here we're taking some cosines, right, that line up on the grid lines, and then we're adding them together, and then, you know, scaling right here. The reason we're adding them instead of taking a max is it's more continuous. It doesn't generate artifacts. How long have we had our own shading language? It's like 6 years. Braid Anniversary has HLSL that we cross compile or something. But for the entire life of this project, or most of the life of this project, we've had custom shading language. Does this SL compile to something else? It compiles to whatever we need to run on the target platform. There are too many shading languages. Let's make another shading language. I know, it's stupid. We shouldn't have had to do this. But they decided to make programming completely retarded, and we just have to deal with that, right? I mean, NVIDIA is doing this slang thing now that might be what we use on the next project, so we don't have to do this again. But like, maybe not. Maybe we still need to pre-process before slang because it's also stupid. I don't know. There's some, why we make our own shading language? Because at least this way we're in control of being able to introspect it and cross-compile it, right? If you're using someone else's API that doesn't, like, we can send, we can read data about what's in the shader and all this stuff that's important to do, that if you're using someone's black box API and they don't give you a way to do that, as graphics drivers do not do because graphics drivers are terrible, then you just don't have all this capability that you should have, right? And that you need because you have a large, complicated program, you know, dealing with this other thing. Slang doesn't support bindless. Okay, well, they're going to have to fix that. Dude, even we support bindless. Jeez. Okay. Anyway, so this is one of the grid factors, and then the noise is another one. It's probably, yeah, it's in this new grid lines foam. So I have some noise functions that I do. Dude, I remember when GPUs were new and you could have 8 assembly instructions max. And now it's like we have this 700 line program. It's insane that this is running on every pixel. We're going to need to cut it down. We've already cut down a bunch of stuff and simplified this, but we're going to cut it down more. But the point is, we use the same grid factor that we got from the other thing. Let's see. We're reminding ourselves. Yeah, that get grid factor. Oh, no, this is a different function. It's here. But it's basically doing a similar thing. We're just, in this case, instead of doing cosine, because I didn't like the way that looked, it was like too fat. We're taking like 1D functions and, you know, adding them and then putting a circle in the corner because I wanted vertices to be a little more thick. Okay. Now, this should go away actually though. This was a temporary thing I did to get the gridding working. What we want to do is use a texture. So let's figure out the texture that someone on the team has added. He emailed me, which I am looking in. Okay. It's called water grid height mask a.tga. So let's, dude, I've got so many web pages open. I've got Dr. Disrespect. I've got GDC Wheel Robot. I've got GDC Vault. I've just closed all of those. I've got Twitch chat. All right. Anyway, so we're looking for. We're gonna be foolish and try to use Windows search. Oh, it found it. Oh my God. Let's just look at this. Can I just? Why is Microsoft Paint not in here? Okay, we'll do it in Photoshop for now. Okay. Wow, that's not very creative. Honestly. But it's fine. Wait. Why is it scaled like this? That's annoying. Okay. So we have to multiply the UVs by 4. I guess it lets you put variation in, is the point, right? So my goal is, instead of using the math, we're just going to sample this texture. For, I guess, both the wave heights and the foam. I was hoping it would be a cooler texture, but it's fine. Like, instead of coming up with math that looks right, the artist can just pull this into Photoshop if he wants a different look and just like mess with it, right? He could put irregularities and whatever, and it's all great. Okay, so we need to do 2 things at least, 3 things at least, right? We need to load this texture in the game. We need to send it to the shader, and then we need to use it in the shader. And we can't really do anything that looks cool until we do those first two things. So, but here's what we could do. This is where we're reading the vertex paint. Do we do that here? No. Hold on, I misspelled it. No, we're not. Okay, so we set it here in the vertex shader. I'm just going to set this to 1 instead. And that should, there we go. So instead of reading that paint thing that I did, which we'll save by the way, it's just got maximum grid square everywhere right now. Or 1.0. 1.0, I mean, I guess we could turn it up, right? Let's go to 10. I mean, oh God, you know what? We have to go to 11. Ours goes to 11. Yeah. So you can see that's what it looks like when you go to 11. We'll set it back to 1. Yeah, we need to put that together with the 6-minute abs or whatever, the 7-minute abs. All right, so the point being, we have grid squares in our video game. Why? By the way, I had a really good idea today because I was like, why am I making video games with my life? Like, what would I do if I actually wanted to ride the AI wave and do a company that could actually be like a massively successful, like $1 trillion company? And I actually have an idea for what that could be. I thought about it today and I'm like, oh, dude, this is a particular angle nobody's doing. But instead of doing that, I'm going to make video games. All right. I hope you're happy. I hope you're happy. Okay. Um, so what's the idea? I'm not going to say the idea. I might do it still later. It's actually a good idea. It's like, because I started thinking about it just whimsically, like, wow, this whole AI thing is such a dumb trend full of such low quality startups. And then I was like, wait, what would I do? Oh, that's what. Yeah. So I know what I would do if I wanted $1 billion. Um, might still do it. Who knows? If this game makes a lot of money, it might not be too late to do it. Okay. So, so, right. So we have to load the texture. Do we still have it in the paste buffer? Yes. Okay, so we're just going to hard code this at first, and then later, I think it's in water rendering. I need to find update per instance ocean parameters. Okay, so we have this ocean params struct. Maybe that's here. Ocean params. Nope, that is probably in rendering somewhere. Let's find it. Ocean params. This is how working with GPUs just makes everything harder because you can't just write the code you want to write. You have to write all the code. It's like everything in modern programming, right? You have to write the code around the code you want to write that eventually lets you get kind of to the code that you want to write, but never quite there. Okay. So now I don't know. That's weird. This doesn't even have tint map in it or anything. Why is that? That's so weird. Um, okay. Let's put I didn't write this code, but I'm like, why do we have this on? Anyway, so the at shader here means this will automatically get transpiled into shader code, right? When we compile at compile time. Okay. For the reflection plane. Okay. So now why? So this is per instance ocean parameters. Is there a different ocean parameters? There's constants for ocean parameters C. Oh, this is just generic stuff. Let's look at that. Like these should all be put together actually, right? Oh, maybe not. I'm not sure. Okay. Ocean params constants. So that's in render frame also. Params constants. Like, why are these different? Because we experimented with a bunch of different shaders. Okay. Reflection map depth. Shore distance texture. Yeah, this is where we should put it because this is where everything is. So we're going to put grid texture right here. So this is a buffer that gets filled out on the CPU, gets put into a command buffer, gets sent to the GPU, and then that's how the GPU knows what texture maps to read and stuff. But of course, when we send this to the GPU, we also need to like tell it like, hey, bro. Now, this doesn't have a shader tag on it, so I'm not sure how the GPU knows about these variables. But I did add this riverness texture also. I just don't remember everything I did. That was like 3 weeks ago. Okay. Anyway, grid texture. So, where do we set the riverness? We'll just put it right next to there. Riverness. Oh, wait. Where does that get set? Riverness texture. What? Did we not set it here? Dynamic water ripple texture. So this is happening in the FFT dispatch. That's because we're using that as a render target. Maybe these aren't actually doing anything. Let me just look at when I did riverness texture, who else? There's not very many references to it. Okay, so in shader globals, add ocean parameters component. I see. So, yeah, okay. We actually don't want it here then. Let's just, I'm going to make sure that's in Emacs. So this is like for all oceans, but none of this is right. It's like this is meant to be for all ocean rendering or something, but all these are like, well, these are, maybe it's fine. I don't know. But this is like ocean params, and then C is ocean, yeah, ocean params constants. Okay, whatever. Okay, here, we're literally going to do this temporarily. We're going to put a no check in. Because where do we set the riverness? Oh, I guess down there, right? Yeah. So we're going to say grid texture is a texture map. I think that's how we do it. It's been a long time. Grid texture is find texture catalog, comma, that without the extension. If I forget if valid is the right name, log error, unable to load the grid texture in add ocean. This component, right? We're being pretty paranoid because this is new, right? Okay. We don't want colon down here. That's not good. And then we're going to go here, I guess if grid texture. It doesn't really matter. We could probably call this with null, but grid texture grid texture. I mean, maybe that should work. Do I need the address? We'll see what happens. So we're going to compile. We get rid of the pretty pictures for a minute. Oops, that's running, not compiling. Okay, valid is not the right member. Texture map. Mr. Streamer, if you used autocomplete. Oh, it's just called texture. Okay, I still say texture map everywhere because that's what I said when I started the game. All right. Oh, it's in resource. Loaded. It's loaded. All right. Riverness Everdeen. Okay, grid texture is not a member of Ocean Param. Oh, did I put it? Hold on. Let's put it back there. Oh, am I right? Why did that? Oh, it's the European cores, guys. I gotta switch back to the Threadripper. I'm sorry. I'm very unhappy with this computer. Okay, so this won't do anything yet. So in this ocean shader, so this is where this stuff is, and we're going to put grid texture there. And then, oh, we don't need to recompile for that. Socko debug, Socko ban. Socko ban. Here I am. Play me like a Socko ban. Okay, so I don't see an error message for that. So maybe it's working. Here's how we find out. Here is the awesome shader hacksaw thing. Okay. This is always how an experienced graphics programmer writes shaders. Okay. So we have this input.position.xy, which is our position in world space. We go down to the bottom of the shader where we output the color. And it's very common to do a thing like this. Like, for example, what if I say .z equals 1 and .y equals 1? What if I do that? Then it overwrites all the work from previously in the shader, and now we get this nice cyan color. What if I want violet? Then we can do that also. Look how long it takes to recompile the shader. So what you do is, like, to make sure your texture works, you ignore literally everything else in the shader. You go down here and you say float gridness is sample texture from grid texture, not frag view UV, but world, what was it? World position .xy, and then the dot, I mean, we could say R there or whatever. That's still not going to do anything. Oh, we got an error already. World position, wait, it's not, what? What's it called? Is it input dot position? Input, yeah, it's input dot position. So we input dot position. All right, that's still not going to do anything, but we're back to here. And now we're going to say output color dot xyz equals gridness. So now we're just going to see if we're success. There we go. We are successfully sampling the texture. That's great, because the number one problem in graphics programming is nothing happens when you do this. And then you're like, what the hell? So we know we're loading the texture off disk. We're setting it correctly in the struct to the shader. The shader is able to read it. so all the fuckitude of shader programming has now been dealt with, and we now just get to play around. So, you know, as you noticed, it was 4x4, right? So let's say grid texture scale, grid texture UV scale is 4. I got to remember I'm in a poopy programming language here. The grid texture is authored 4x4 squares, authored as, so we can introduce per square variation, etc. And then we'll go times this, right? You know what? People are going to be like, Mr. Streamer, why? Oh, God. We went the wrong way. Reverse. Reverse. There we go. There we go. Okay, so people are going to be like, Mr. Streamer. Mr. Streamer, why don't you have syntax coloring? So we're going to go into C mode in Emacs. I guess we have to do C mode. C mode. I don't know why that was so hard. All right, so now we have syntax coloring. It looks shifted by 50%. You are correct. You are correct. So this is going to be... Because like the coordinate system is at the center of the square is the integer, right? So 0, 0 is in the middle of a square, but the edge of a texture. This is like the classic... There's so much of this in graphics programming, it's silly. But we're going to go plus vec 2.5.5. It really probably doesn't matter which of those we do. Yeah, there you go. So that's our grid. That's great. So now we could get rid of that. And we can replace our get grid factor. Oh, it's in grid. Oh, no. Is this going to be able to see the... I think so. Let's see. Hopefully this works. All right, so instead of all this, just going to comment all that out. We're going to go, it's going to be much faster, hopefully. I mean, depending on if grid factor vec to position, and we're just going to go. The other reason not to be one of these programmers who can't do anything without an IDE is like, what happens when you switch languages and you're working on a shader now? What are you going to do? Oh, there's no methods in the shader. I don't know how to know what functions can get called because I can't hit dot and then it doesn't pop up the menus. It's like, well, deal with it. Deal with it. Deal with it. All right, so maybe that'll work. Oh, God. So here's the thing. Somebody allowed our engine to start crashing sometimes when you make compile errors, and that makes me very angry because editing shaders is supposed to be this fun process. And, like, nobody fixed it. So then I fired someone, and, like, I still haven't fixed it. So, I don't know. Like, there's just too much to do. It doesn't see grid texture. But maybe not. Oh, this is probably. So the problem probably is that we include this in other places. Let's fire people until problem fixed. I mean, we're a pretty small company at this point. like, all right, grid lines. So who includes this? Like, it probably is literally 1 hour or less to fix, but I just don't work with that part of the shader system. And so I always have this hesitance to dive into that code. Maybe that could be a separate stream sometime. But you're not supposed to crash your engine when you edit a shader wrong. Like, that's ridiculous. Shaders, and we're going to look for, whatever, any file in there. And we're going to look for who includes this. Yeah, so the particle simulation includes grid lines because it's doing a thing. And I'm going to comment that out for now. Because that's an effect we don't even know if we're going to keep. That might not be the only problem. Maybe this can't see it either, but let's just take care of that. All right. So we're going to go no check-in, and we're going to go grid factor, no check-in, float grid factor equals 0. So now we may have another problem. So let's just see. In fact, probability is that we do. Oh, there we go. What is happening here? Undeclared. Oh, input. Right, because I didn't change the variable name. Duh. This is not input. We called it position. It's just position. Boom. Hey, look. We have a grid factor for the things. I guess the old grid factor, either the old grid factor used the vertex paint or something, but this is great. So we're sampling the texture and now we're using it as the grid heights. Awesome. Now, the commented out code below is the old procedural grid code. We now sample a grayscale texture to determine grid heights. We might add noise and stuff to this also. Like right now, there's not really noise. We'll see. I definitely want to just keep the ocean shader cheap so it doesn't destroy my battery every time I run the thing. Okay, so do we do that here? I don't see any. No, there's no vertex paint parameter here. So I kind of wonder why. Oh, because I still disabled the vertex paint, right? Right? Vert alpha. Whoops. Yeah, it was this. So let's get rid of that. Oh, come on, bro. What's going on now? See, this is what makes me really mad. Invalid arg. What's the invalid arg? Okay, we just didn't even get an error. Oh, because we're never setting this. Yeah. All right. This is how the water looks inside Hollow Earth. Okay. I've never been to Hollow Earth, but I'm sure it's cool. There's a thin grid and a fat wavy grid. No, the thin grid that you're seeing is actually, I'll show you what that is. That's actually terrain on the bottom of the, see how this is like very gritty? That's what this is down here under the water, right? So in a real game, we wouldn't have strong gridding on this. This is just here because this is like, this is the programmer art. So you wouldn't see that in the final scene. Note also how there's a discontinuity between these. We'll deal with that later. That's actually partially the vertex paint. Okay. So I guess the height of our grayscale is different than before. Let's actually. Can we clear this out? Wait, is this the wrong? No, this should be this. I guess I'm able to clear it out, but like, it's actually pretty hard. So I'm not sure what to think about that. What I would say is, like, maybe maybe we just need to scale that down. Because I don't, let's just try this, for example. This isn't doing anything. Weirdly. What if we multiply it by 0? Okay. Now I'm like, what is happening here? Now I'm just like, what is the computer machine doing? It's not changing at all. Okay, are we not using this variable? Let's move it. So, by the way, you never really, okay, that's for foam. Wait, we're literally not using this variable at all. Okay, I guess that was just a dead variable. Like, that's what we deleted. It was not being used. Whoops. Now what? Oh, wait, it was being used. Ah, at the foam. Okay, I missed that. All right. So we're going to do this. Is there any grid factor below here? Let's just check. Grid factor, no. So we're going to leave this in the new foam right now. We're going to change the foam implementation as well, probably. Damn it, dude. See, this is what's so stupid about the thing. Like, look, okay, I accidentally left a line in. Can you please not exit the program like this was Rust? All right. So stupid. Like having all this machinery and it exits the program. It just makes me angry that I paid so many people for so many years and this is what we have. Okay. Okay, so that was that. Wave grid modify is getting its own grid factor. And we're gonna have this be the same. Oh, you know what? Let's move this back up. Anyway, because we want it to be, well, actually, that's a fine place. Wave grid, no, where is that? Wave grid modifies in FFT finite differences, which is down here, which is below. Okay, so we're fine. So we're going to pass grid factor. Oh, we say grid height factor. Oh, times grid factor. Okay. Let's do this. Okay. So we're going to pass that into FFT finite differences, which passes it to wave grid modify, which used to have this, it was just a scale and it would compute this. And now we're going to say grid factor. We'll just say grid factor. It's fine. And this is just sort of a heuristic. I don't know. So where's original height? Oh, that gets passed in. Yeah. I mean, do we want to keep that? I don't know. We made a mistake. Modifier scale. Yeah, we don't have that. I think we just take that out. The add factor is just a really small factor that we're using to make it pop. All right. So, do we still have our... Okay, we're not multiplying it down yet. So we could do this just to make sure, because we should have some remnants of our vertex paint around that we should be able to see. Yeah, there you go. Okay, that's obviously overflowing and stuff, which is not great. That's something we could handle later. Let's go to 11 instead of 100. It still looks wrong. Are we doing negative numbers somehow? Are we treating this as a signed floating point in some way? I don't think so, but... Let's see. Yeah. Okay, this is one of these, like, oh, great. We're just sampling this texture, but we're getting negative numbers? Oh, no, that's not it. Sorry. Actually, because the times 10 will clamp us at 1. No, it wasn't negative numbers. It's just we're over, if we're too high, we're like causing something bad to happen somewhere. All right. So this is weird because we're not... we're not really seeing the waves. Let's do this. Grid factor equals 1. So this is as if we had sprayed the whole map. And then we'll just make it, we'll make it visible. So I'm just going to play around with these constants because I don't know why it's so different. I'm not sure what... Like, this is weird. We're not seeing... Oh. Oh, shoot. Okay. So the current grid factor thing that we did is pre-multiplied. And what that means is that in the middles of the squares, we can never have any effect. That's not what we want. We want to know two different numbers. We want to know what we'll call the grid factor, which is like how intensely should we do the gridding, but then we also want to know the grid height separately. All right. And that sucks because, you know, we have to pass this down. Calling this grid height factor is confusing. So we're just going to call this grid factor. We're going to call this grid factor. Mr. Streamer, if you use the AI, it would write all the code for you. You just tell it that you want a lemon béarnaise. And it's awesome. It'll all work. You're stupid and don't understand the future. You don't understand the future. So I'm changing the names of all these. This is grid height. But we're calling it get grid factor, no check-in. Rename this. It's confusing. We'll do that. But now we have to change anything called grid factor. This is grid height. Oh my God, this is so confusing. Okay, so this is our new thing. All right. Okay, well, we have a shader. So now we're not really using these. So what we want to do is say grid factor is, how did we use this before? I don't remember what, I guess modifiers, okay, this is really confusing. Old grid factor is our new grid height. Modifier scale, maybe that was a better name than grid factor. Dude, I don't know. Except when you get a lot of variables, it's like modifier of what? Modifier of what? Okay, so let's just retranslate. Okay, so first of all, setting it to 1, of course, is not that productive. So is grid height and multiply factor is going to be 0.8 plus grid factor times grid height. I mean, I've swapped them around left to right or whatever. Okay, so that might be like what it was. And we still can't really see it. Let's double check that the things we are passing in are so h equals grid factor is confusing. Is that the order that we have them in wave grid modify? Yeah, factor height, okay. Grid factor. We got to rename that function. We could call it mask or something instead of. I mean, that really should be the thing. So I guess again, I don't know. I feel like this should be. Let's try that. See if that sticks out. Like, why don't we see that? Maybe because the grid factor is 0. Why can't we see our add factor literally at all? Return grid height times original height. This should be very obvious because it's a 0 to 1 times whatever. Okay, that is very obvious. See that? Okay, we're back on the map. I mean, it's somewhat. So the deal is we send back these heights and then we take finite differences to regenerate normals there. Okay. Okay, this is stupid. I don't know why this wasn't parenthesized. Um, so we want to multiply down because we don't want to kill the waves all the way down. But we at the low, when grid height is 0, we multiply by 0.8. When grid height is 1, we multiply by 1.8. And of course, we can mess around with this. The normal things. Let's just not, we should put a grid factor here, but maybe I could call that grid scale. I don't know. Okay, that is not good for some reason. Oh, because we're not, sorry, it's multiply factor. Add factor equals 0 for now. So we're back to returning this. We need the original height in there or we don't have the waves. You know, basically we generate these waves and then we pass them in. Okay, I think I can see the grid, but it's very faint. Okay, so that's our same like extreme. What if we go... Like, this is really weird. I'm having a lot of trouble getting a highly visible grid, which is really strange. Maybe that's why I was doing add factor before. But yeah, you see how the waves are sort of... So part of it is, again, we're relying on like reflections to be able to see the things. Anyway, this is supposed to be a subtle effect, right? But we definitely want to tune it so it can be highly visible, right? Like it's weirdly just not that, but you know, part of this is add factor. All right, so add factor is going to be, let's just say it's grid height times grid factor. That's what we had before. Let's do that, right? So that's like we're theoretically adding to the height. And I'm kind of mystified that I can't see that. I'm not sure why I can't see it. Like here it's just add factor. I mean, we could subtract and add, right? It doesn't matter. In fact, maybe that's bad because we don't really want it to go below 0. Yeah, I'm not sure why. Let's crank this up. Okay, what? So, oh, because the grid factor is probably 0, right? In most of the places. Okay, why can't I see this? This is ridiculous. Is grid height 0? Why is grid height 0? That's just our get grid factor that we verified works. Are we still using this grid mask? Oh, we're setting it. All right, so that's the noise output. It looks like the waves get dampened. Well, you might expect that. So the thing is, again, we're taking finite differences to generate the vertex normals. And we're not actually doing any geometric displacement. So what you see is the normals. Messing with the lighting, the incoming lighting, right, from the reflection map and all that. So this is kind of a mystery, because I believe it's very weird, because the old one was very visible, and this shouldn't in principle be different, right? Remember the old one, how great that looked? I mean, great for programmer art. So why can't we get it to show up like that, is the question. How long has that been there? Okay. Did I just leave that line there and I haven't been eating enough calories to know? Has that been there for like 10 minutes? Because that's a Twitter clip right there. Oh yeah, I guess we were working on add factor, weren't we? No, okay, never mind. That was intentional because it was the add factor that was not showing up. We're turning off the multiply to see that. And I do think I maybe see some gridding, but it's really difficult. And if I'm multiplying this by 100, oh no, guys. Okay, what I'm doing is wrong. Okay, so sometimes you think you have a little bug and you're like, oh, it's just the factors are weird, or it's just graphics, it's hard to see, or whatever. And then you're like, okay, we'll just crank the values and I'm going to tell my boss this is the best it can look. If you think I should be doing better, you don't understand graphics and whatever. By the way, people fucking said that to me all the time. The problem is, as I have been saying, this is called from inside FFT, which does finite differences. What does finite differences mean? It means we sample the values at small positional offsets from each other. We get the z value, and then we interpolate. Well, I am passing in the grid factor at the center. And we're using the same value across the finite differences. So when we subtract this, the difference will always be 0 because we're passing in the same value. We need to be sampling the different grid factor at the different positions, which I knew when I wrote this code up here. You see where we're generating a grid factor, but I was like, oh, I want to save sampling the texture. I don't want to do that. So let's just do math. I forgot the thing that I knew. So we actually don't want to pass this in, but for now we'll ignore it. we're going to say grid height equals get grid factor. Maybe we'll change the name back. I don't know. Get grid factor of whatever the position is in here. And this means we're sampling the texture a bunch of times. But maybe GPUs are fast. I don't know. All right. Bro, look at how much stronger that is. Can you tell where the grid is, guys? Can you tell where the grid is? I can't see the grid. Okay. That's why we had add factor turned way down before, by the way, is because when you're doing this. So first let's do grid factor, which is the mask. I'm going to call grid factor grid mask. We're going to rename everything. All right. So this one on the right isn't painted at all. The one on the left is painted, but like, dude, this add factor is dominating, right? Probably because our multiply factor is 1. So we'll do that, but that's still not going to do that much. Okay. Anyway, so we're going to turn this down. So that's our add factor. It's very strong still. And then our multiply factor is going to be mix between the mix means lerp. I think we also have lerp. Let's try lerp because I like that better. Now, technically, we also should sample the grid factor every time. But I'm not doing that. So, wow, the add factor is really a lot. I guess because, yeah, it's scaled to 1.0. 1.0 would be like 2/3 as high as the character. Okay, so you see when you do things that make sense, then everything makes sense. Now, I will say, though, to be fair, it's an idea that was spread across 3 functions that I had to remind myself of. Let's try no add factor. See what it looks like. Okay, that's very subtle. So the multiply factor is like, you know, what are we doing? But we want these to at least be comparable so that we can tune them, because we would like to maybe tune them on a per level basis or whatever. So let's make this stronger. So we lerp toward 1 because when, oh wait, yeah, when grid factor is 0, we just want, we want the old waves to be unchanged, and when grid factor is 1, then we want to do this, right? So can we say lerp here? Is that the same thing? It didn't take any time to recompile the shader. I don't know what that means. Okay, so we want this to be more visible just by multiply. I don't know. Like, the thing is, because we're taking the finite differences, it might be hard to make it. Okay, that's pretty damn extreme, and you still only see it somewhere. Oh, you know what? Let's take out the grid factor for a minute. Because we want to see it as if it's painted everywhere. All right. So this is what it is at max. You see the tiles. Sometimes it's harder. So like with the light background, you can't really see them that well in the contrast. But we're killing down the wave height, right? Extremely. This is probably too much. Let's try making the highs higher though, because there we're amplifying the wave height. All right. Great. And then let's go down to that. We don't want the ocean to be super smooth everywhere. In fact, honestly, okay, so this is like at maximum, which we're never really going to turn it up to. But I feel pretty okay with that. And then let's do, okay, so let's go grid factor equals 1. And we're going to put this back. But so now for both of these, we've got it at max. And let's try turning down. Well, the add factor is not too bad here, right? Especially we could put some noise or something. Like, isn't that cool? Have you seen a grid-based game with grid-based water this cool? And we haven't even added the foam or the particles. The grid below feels cluttery. Yeah, the grid below is not going to be there eventually. Don't worry about it. In fact, let's try to clear that out. How do I do this? Oh, I don't remember. It was one of these RGB channels. Let's just clear them out. Clear them out. Clear. It's not doing it. I don't know how to erase. I thought it was right click to erase. Swap colors. Let's left click. Why isn't it? Is that paint on the button? No. I don't understand the paint system. I mean, maybe it's doing it slowly. Do you feel like it's getting better? Oh, I was in the wrong paint mode, maybe. I don't know. I don't know, guys. Anyway, we'll figure that out later. The art team knows how to use that stuff. Well, if I paint, so most other things in this scene, besides the water, don't have any shader on them that reacts to vertex paint. We would need to be in a different scene that has like lots of inanimates or whatever. Anyway, oh, maybe the radius was a little too small. There we go. Big ass radius. Still not doing anything. Oh, but I don't know what I was doing when I painted that. That used to be very uniform, and I painted it. Oh, God. All right. Anyway. Maybe it's airbrush messing it up. I don't know what that does. Okay, whatever. Oh, wait, our color mask got clear. What happened? Like, how long has that been that way? Maybe I clicked reset colors accidentally. Okay, I don't know how this works. All right, alpha is what we're going to paint now. So we're just going to try using this again for a little bit at these settings. And okay, wait, I deleted grid factor equals 1, but it didn't, you know, usually like it didn't even stop to recompile for some reason. maybe we rejected it going to the shader somehow. Let's go to 11. Yeah. All right. So we delete that. So this is just using whatever the grid factors are that are painted in then, and I guess they're pretty high. This is the thing. Well, okay. Let's see. If we say grid factor equals 0.5, how does that look? Because we want that to be pretty reasonable. I mean, I feel like the grid lines are sharp, but that's something that could be adjusted in the texture, you know? I forgot a semicolon. We use semicolons every day. Yeah, like I feel like this is too sharp, but this is something we can tweak. The main objective for today was just to sort of use this, right? Yeah, you know, it's... Okay, hold on. I feel like the add factor is probably overpowering. No, it's the really? Okay, let's tune the add factor so it seems reasonable. So this is at 0, or close to 0. This is at 0.5. That's pretty good. This is at 1. Okay, that's pretty good. Nice. Okay. Let's put add factor at 0. And now let's tune multiply factor. So this is at 1. And like, it's not doing anything again. Why is it not doing anything again? Oh, because our grid factor is not changing. Wait, grid height. Grid height. No, grid height is changing. So why did this disappear again? Oh, because our oh, shoot. Guys, this is supposed to be 1 when grid fact... I have these parameters backwards. Duh! So since I added that, it was broken. Okay, that's 1.0. This is 0.5. There's so many factors flying around. That's another reason why calling it factor is confusing, because I have multiply factor and add factor. That's 0.5. That seems reasonable. And this is very low. Yeah. Okay. Okay. So now we put them both back. And 0.5. Right? And 0.2. Yeah. I think that's good. What I'm going to say is I think the grid's a little sharp, but again, that's a content thing. And it's a little straight. Like we can stylize it. You saw the texture. It's literally robo texture, right? So we could start messing with stuff here. In fact, I mean, can we do a Photoshop noise thing? How would we do this? I forget how to add. How do we add an effect layer? I haven't done this in so long. Okay, so hold on. Do this. Oh, we can just FX on this. We don't need a new layer. Okay. Trash. I'm just going to do an effects. Isn't there a noise in here? What the hell is satin? Satin filter. You know, I think these glows have have a noise in them. Noise. Is there any escape from no? Okay, but this is plugins. Discover plug. No, I don't want to discover plugins. God. Is there just any easy noise that I can do? I give up. Isn't it just filter noise? Yeah, I hope so. Ah, this is what I was looking for. Like I had a vague memory of this. Okay. I mean, look at that. Can't I change the scale? Bro, there's no scale? What kind of butt-ass noise function is this? That's completely useless. Like this is what people get for their $1 million a year that they pay in Photoshop. I don't know. What's that going to do? Is that better? Not really. Okay, whatever. I give up. So anyway, I could try this. Maybe it looks good in game. I mean, will I be able to tell it all? Let's try it. Save. No, oh, we have to save as. Remember when Photoshop got really annoying about save as? Such a poop. I can't even. Oh, you have to export. God, it's fucking. Like, just save back the file that I dragged. How hard is that? Dumbass. Okay, we can't even save TGA without a plugin. Forget it. Forget it. Control S. No, they did a big thing where they gimped Photoshop a long time ago. And it doesn't do what you want anymore. I think they were like, we need to capture more people into the PSD format, so please increase the friction in exporting other formats. All right. So we're going to do this. We're going to put back that. I'm going to call this grid sample. And wait, was that height? That was height. Yeah. Grid sample. Okay. There's that. We get rid of this. Okay, FFT, finite differences. Now I'm going to put a comment as well. Let's make sure this compiles. Okay, wave grid modify. Note, we are sampling grid sample per FFT sample position. Expensive? If we don't do this, the grid will not appear very well. I think we still have too much add factor. Like, we shouldn't use that much add factor, honestly. Yeah, see how now when there's sharp lines, when the waves are low, they're really distinct, but when the big waves come up, they sort of wipe out the lines themselves, and that's pretty cool and organic, right? See what I'm saying? Okay. If we don't do this, the grid will not appear very well. However, we are passing in grid factor from, we're going to have to rename this, the outer call so it's constant across the finite differences. If we want this to be more accurate, we could sample it here as well, though I forgot what I was thinking. Though it is controlled by vertex paint, and vertex paint is generally very low frequency. In other words, it won't change that much from sample to sample. Maybe bake the grid factor later. No, I mean, it is baked in as much as it can be. It's just in a texture. Oh, you mean this? See, the grid factor, it's confusing. Our name's, if you meant this, the whole point is we want it to be controllable by a bitmap so that the artist can change it from level to level and help create moods, right? Okay. Now what? Well, I want to rename these confusing variables again. So get grid factor is going to be grid sample. We're going to have to change that back in the vertex shader. Okay, grid sample. Now there's some redundant math because we're calling this a bunch of times and we're adding this vec2 and timesing the scale multiple times, but like the optimizer is supposed to be able to catch that stuff. Oops. The optimizer is supposed to be able to catch that stuff. Get grid factor. Okay, I'm still calling it. And then we'll put back the foam. So this is also like grid factor, which is sucks. All right. Grid, let's call this grid sample. Consistent terminology. Grid height is going to be grid sample. Okay. Save that out. And then we're going to say, okay, wait. Okay, I'm just making sure we're not resetting it to 0 here. This still might be too much. I don't know. Like, I don't know what's going on. Okay, so we're going to go back down to the foam. We want to turn that back on, but have it be controlled by this. So grid sample is here. Grid factor is that. See, I want to call this mask, but we have a mask. Okay. Like, see, we're getting a little bit of the foam out here. So it's just like, it's not tuned in parallel with this. So I'm not sure. Maybe we don't like that. Like, this POW was to make us go along. Oh, we need to add the vec2 here. Maybe. That doesn't seem to be helping that much. Okay, so let's just say times 3. Let's just make it visible, right? Okay, times 33. It's the first episode of Battlestar Galactica. Okay, that is clearly actually off by a square, which is weird. Are we offsetting down here somewhere? I don't even know. That's weird. Okay, that's very strange. So let's reduce the POW because we want more uniform. See that? Okay. So we add these purlin noises. And instead of doing this, let's just do this. Oh boy. You know what we don't have here? Okay. We're adding probably too much noise. So when we make this sum for all the grid noise, we're going to do that. We're going to do that. Okay. Let's go back. So here we're basically hard masking this. We could do something softer here, but it doesn't matter until you get in the general look that you want. I'm confused. Did I accidentally get our old function here. I mean, we're saying get grid sample. We're going grid factor new foam. Okay. How are we using that at all? Maybe we're not. Oh, down there. And then grid noise times equals, right, the vertex paint. Okay, that's fine, I guess. It's weird. Okay, I guess this is brighter at the corners than the middle. It doesn't quite look like that in the bitmap, but when we threshold it here, I believe it, right? I believe it. So we're just going to turn down the noise a little bit. This is all temporary anyway. Let's not POW this. Put 1.0 here for now. We're not optimizing. We're not worried about removing the POW. So yeah, the corners is pretty annoying actually. This is not the right thing. Having the corners be this much bigger. I mean, maybe it's fine. But I want to see more lines sometimes. Does the grid texture encode the distance to the edge? No, it is literally a grayscale mask texture. It is the simplest thing. Isn't that just a fault of the bitmap image? Sort of, but there's a question. What if the best thing for your waves is not as good as everything else? Although, again, that's a thing you could stylize. Like, you could have more corner on some levels, right? Etc. Let's go back to this. We're gonna I thought this was supposed to erase. Maybe it's... Oh, do I have to have the entity selected? I bet I do, huh? Yeah, oh, that was this mistake the whole time, guys. Okay, hold on. Let's go back here. Let's clear this out. Yeah, okay, see that? Now I understand the system. Now I get it. All right. I knew that before, but I kind of forgot. All right, so let's turn this down so we could maybe get some intermediate. See, this foam is not that controllable right now. I mean, it's just hard to get corner on it. Like, I guess, okay, we can do a similar thing where we hard set it to 1 and make sure we can see, or sorry, I meant it's hard to get lines. So just scaling it down, of course, is not going to be that good. It's not really going to do anything except scale it relative to the other noise, right? The problem is just it's a lot dark. Like, okay, How do I get my windows back in Photoshop? What is going on? How do I get my sidebars and stuff? Why is it hanging right now? What? There's literally just a bitmap. All right, Photoshop is punishing me. Tab. Ah, thank you. So we want the airdropper or the color sample Holio. So here at the corner, it's something. I mean, it's basically up there. I don't know what number that is. It won't tell me. Here it's like half. Okay. Yeah, see, that's a problem. We need to POW by less than 1, and the problem is it might make the middle too big, but we're just going to do this. Maybe we want a separate grid texture for foam, right? I don't know. That's a possibility. We could pass in another texture. I'll consult with the artist instead of just doing that. All right. So now let's go a little less. Yeah, that's kind of good. And then like this is still the foam is sort of the secondary part of this, but I mean, right now the foam looks more overpowering relative to the waves, right? Like we don't want to see as much foam generally. Okay. Here I'm just doing the cutoff. Let's do this. Yeah, it's still, there's too much in the corner. So let's hit the, let's go back down to POW 0.5. Did that do anything? Yeah, it did. Okay. So then adjust this. I mean, the foam isn't, you know, we need to do a little more to make that artist controlled. So we're just finding a happy medium here. All right, so if I go here and I'm in the alpha and I paint now, we get an equal proportion. So there's only one channel for these. So we get as much foam as we get wave gridding. I don't really like that because the wave gridding is cool and the foam covers it up, right? Sort of. So that's a little bit not great. But the foam is like, you know, that's an open topic for discussion anyway. Like this isn't what it would look like and whatever. Okay, for now I'm going to turn it weight. Like I like it makes the gridding very clear, but like it covers up the other wave effect. So let's just make it, actually let's do this. Grid mask is being used. We could just massively turn down the color. I mean, that's a little weird. It looks like ghost foam now. Instead of making it monochrome, We could do this. Oops. Grid knows. Grid knows. Now I don't see it at all. I mean, that looks a little better, doesn't it? It looks a little less cartoony. Yeah. Okay, well that... I mean, we definitely want something subtler than what we've been doing. It still doesn't look good, but like this might be the stopping point for today. Although I do think I would crank the brightness here. I don't know. It still looks weird and like non-physical in a way. Maybe it's because it's not being distorted by the wave function the same way. I don't know. Less looks best. Yeah, maybe. Grid knows. Anyway, that was one of the main things I wanted to do today. We're 5 hours in the stream, so I might call it here. The next thing we're going to do is make these foams not frickin' shrink when they disappear. See how it shrinks? We might do that, I don't know, tonight or something. But there we go. We had a learning today. We read about Rust, the new exciting programming language Rust. And we did some ocean squares. See, it still never totally goes away unless you really wipe it. So maybe that's not good. But, like, you know, a use of this might be, oh, you're standing in here and you want to see some gridding out to here. So let's put some gridding in. It's not, oh, we have to select it. We have to select it. I forgot that part. Yeah, we're putting gridding in. Putting gridding in. And then you can just kind of see it, right? Just right there on the map. Then you can tweak it. Tweak. Tweak, 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 tweak. And then you can play the game. You know how to play the game. Isn't that great? Yeah, I feel like it's that it doesn't react to the wave heights. It makes it look bad. So maybe that's the next thing. I'm not sure what's the best way to do that. Is the shader outline for characters here to say, if one more person fucking asks me about the outlines, I'm going to delete my Twitch channel. Just guys, shut up. Jesus. Stop it. Let people make their video game. Why do a small percentage of people get really anal about the fact that they don't want outlines on characters? You haven't tried to play the game. It's a puzzle game. You don't know anything at all what it's like to try to play the game. Why are you telling me how it should look? Oh my God. It's almost like reflections are being clamped at the square edges too. I mean, I think it's just that it's a very sharp curvature there. That's my interpretation. I mean, over here, there's a different thing. So in this one place, we actually, we have two different entities right here, and there's a discontinuity between them. So if you mean that line, that's the entity discontinuity. Oh, sorry, that line. Oops, I was even looking at the wrong spot. Right there. Mr. Streamer, are the pixels here to stay, or will you make the game without the pixels? Okay. Thank you, everybody, for coming by. I will now what do you call it? We will now raid someone. 5-hour stream's a bit longer than we've done in a while. It's what happens when it's Saturday and it's cold outside and I don't want to go out. Software and game development. Who do we raid? Oh, look. There's Ryan Fleury doing engine game tools programming. There's Dungeon Mans. Lana is looking at renders of... That's not her game, right? Her game doesn't look like that. Just a little game dev as a treat. Vanilla C, WASM. What? How do those go together? Game Boy. It looks like there's lots of options. What do people like? Who do you want to go visit today? That's her game? Wow, okay. Cool. Daily Game Dev. Elgato Stream Deck. I think it's great that they named it the Stream Deck. Stream Deck, we'll raid Ryan. He's got people. Sorry, I was just trying to copy the name. All right, thanks everyone, and I'll see you later. Have a good day, etc. See you later.